Picture this. You, me, and a sticky pub table, staring at a napkin where I've drawn a lopsided circle for the sun and a shaky line for an uninvited guest cutting across the neighborhood. That guest is called 3IATLAS, and if names had eyebrows, this one would be cocked. It's not from around here. It's the kind of traveler that shows up at the edge of town with dust on its coat, and a story it won't tell unless you buy the next round. And the weirdest part? The way it moves looks less like a lazy space rock and more like someone who's already memorized the bus schedule. Before anyone grabs a tinfoil hat, breathe. We're not saying mothership. We're saying, that's odd. Because this thing isn't just passing through. It's choosing a route that skims all the interesting places, like a tourist who somehow knows which diner does the good pie. Big, dark, quiet, and early in the evening, you might miss it altogether, except the folks with very serious telescopes are squinting and whispering the cosmic version of "you seeing this?" So here's the game we're playing tonight. We're going to walk the line between "it's a rock, calm down," and "what if it's not just a rock?" We'll keep our feet on the ground, our heads tilted up, and our jokes handy. No math quiz, no secret handshake. Just the most human question in the universe, dressed like a modest space pebble. What exactly is 3IATLAS, and why does it feel like it knows more than it's saying? Okay, napkin back on the table. Before we go chasing shadows, let's lay out what 3ITLS actually is in plain English. The 3I bit means third interstellar, as in the third confirmed visitor from beyond our solar system. Interstellar just means it didn't grow up around our sun. It was born under a different star and has been drifting in the dark for a very long time. The Atlas part is the survey that first flagged it, a set of wide-angle telescopes that sweep the sky for anything moving in ways that background stars shouldn't. So the headline is simple. A faint speck shows up moving on a path that doesn't loop the sun. That's the tell. Most local stuff asteroids. Comets are on closed orbits, like marbles swirling in a bowl. 31ATLAS isn't swirling. It's on a one-and-done flyby called a hyperbolic trajectory, which is just a fancy way of saying in, hello, out, bye. How do we know that without equations on a whiteboard? Because we watch where the dot is on night 1, then night 2, then night 10, and a pattern emerges. If you plot those points and extend the line, you don't get a neat oval. You get an open curve that never comes back. The number that tracks how stretched an orbit is. Eccentricity comes out greater than 1, which is the cutoff between bound and passing through. We can estimate the speed relative to the sun from the way the position changes, and we get a healthy inbound clip tens of kilometers per second with uncertainties because the thing is faint and seeing through Earth's atmosphere is like looking up from the bottom of a pool. One dynamicist put it to me this way: if it isn't from here, the math doesn't have to squint very hard to show it. That's our first solid fact. Second thing to get straight: brightness is not size. If you shine a flashlight on a white ping pong ball and a black bowling ball, the ping pong ball can look brighter even though it's tiny. Space rocks are the same way. The reflectivity astronomers call it albedo can vary a lot. Early brightness suggests 3I ATLAS is not tiny. If it's as dark as typical comet crusts, it could be several kilometers across. If it's a bit shinier, you can shave that down. Think ballpark, not blueprint. We're likely in the large enough to matter, small enough to miss with the naked eye zone. People toss around numbers because numbers feel good, but every number here comes with big error bars and a silent asterisk. Depends what it's made of. A comet with a coating like charcoal reflects a few % of sunlight. A surface crusted with fresher ice reflects more. So when you hear, maybe 5 kilometers, maybe 10, translate to, we're still figuring out how glossy the bowling ball is. Third piece, the root. 31ATLAS seems to be coming in on a retrograde path, which means it's going the opposite direction from the planets. Picture traffic around a roundabout, then one quiet car taking the inside lane the other way. That's not rare for interstellar visitors. They don't care about our traffic rules. What's catching eyes is the inclination, the tilt of its path compared to the flat plane where most planets orbit, and the timing of its waypoints. At certain dates, it's conveniently viewable from Earth. At others, it glides past interesting neighborhoods like Mars first and Jupiter later. Now, here's where we keep our balance. Fact, its orbit is pinned down well enough to plan observations months ahead, because gravity is reliable and our measurements add up. Hypothesis. Some of those geometries look unusually lucky, as if the route was preselected for good sightseeing. Speculation. If you wanted to study a solar system without getting too close, you might pick a path that does exactly this. And to be fair, the universe produces odd runs of luck all the time without asking our permission. If you're thinking, wait, didn't we have one of these a few years ago? You're remembering Oumuamua, the skinny mystery baton that refused to grow a tail and nudged away from the sun in a way that set off 1,000 coffee room debates. After that came 2I Borisov, which did the normal comet thing with a pretty coma, a tail, and the chemical breath you expect when fresh ice warms up. 31ATLAS shows up after those two, and the comparisons are irresistible. Compared to Oumuamua, Atlas looks bigger and darker, and so far less weird in how it reflects light. Compared to Borisov, Atlas is shyer about turning on the steam. At distances where some comets start hissing 3 to 4 times Earth-Sun distance, about 450 to 600 million kilometers, it's been quieter than you'd predict for an object with a decent supply of ices. Quiet doesn't mean dead. It can mean crusted. When sunlight bakes outer layers for a long time, dust can seal in the ices, so heat has to dig before it frees anything. One comet researcher said flatly, inactivity is data too. That line is worth bookmarking. Let's slow down and translate a few terms that get tossed around in updates. Perihelion is the closest point to the sun. Aphelion is the farthest. O stands for astronomical unit, the average Earth-Sun distance of about 150 million kilometers, or 93 million miles if you think in road trip units. Spectroscopy is the trick where we split light like a rainbow and look for missing or extra bands. That tell us what chemicals are involved. When people say they see water, what they really see is light at certain wavelengths being absorbed or emitted in ways that match water's signature. Early, far-out data is always faint and fussy. You'll hear cautious phrases like consistent with and tentative. That's not hedge speak. It's honesty about noisy measurements. So why are some folks whispering the 3I Atlas is acting like it knows the bus schedule? Because the sequence of encounters, this much to Mars, that much to the Sun. Later, the giant planet reads to human eyes like a tour. Again, the boring answer is not only possible, but likely. In a galaxy with billions of stars and trillions of rocks, some number of visitors will, by pure chance, thread routes that make great documentaries. There's also selection bias. We notice and track the ones that come close enough to be noticed and tracked. The less cinematic paths slip by without headlines. Still, it's hard not to grin at the neatness of it, and grinning is allowed as long as we label it correctly. A dynamicist put it this way over coffee: low probability isn't the same as zero. Rare is not suspicious by default. Here's what we can say without crossing our wires. The track is steep and retrograde, with a tilt that keeps the object nicely visible for long stretches. The inbound speed is high but not absurd. Something like 30 kilometers per second relative to the sun won't make veteran orbit nerds spit out their tea. The brightness is ticked up as it nears warmer territory, which you'd expect. Sunlight scales with closeness, and even a reluctant comet warms like a cold soda can left on a porch step. There have been claims of weak outgassing, and counterclaims that it's just dust or noise. That will settle as more instruments take their turn. If a proper coma blooms near perihelion, we'll see water and simple carbon compounds in the spectrum. If we don't, we'll be back to that Aoumuamua feeling where the silence has to be explained. What would count as more than just a rock, without jumping to sci-fi? Start with odd accelerations, that is. Movement that doesn't line up with the push and pull of gravity and the gentle shove of sunlight. With Aoumuamua, the tiny extra push away from the sun matched what sunlight pressure could do to a very light, very thin object. With a TLAS, if we saw course changes that look like puffs of gas but can't find the gas, that would be interesting. If we saw thermal behavior, how it warms and cools, that doesn't fit ice and dust, that would be interesting. If radar pinged it and the echoes came back too sharp, too geometric, that would be very interesting. None of that is in hand as of now. We're at the watch and grab all the data you can phase, which is the least glamorous and most important part of astronomy. Another question that's fair to ask: where did this thing come from? We can trace its incoming vector back across the sky and see what it lines up with, but that's like trying to guess a leaf tree from the direction the wind blew it. Space between stars isn't empty. There's thin gas, dust, magnetic fields, and the gravity of everything. Over millions of years, paths get bent and blurred. You'll hear clusters and constellations mentioned, but think of those as broad postal zones, not return addresses. The age angle is fun, though. The ices in interstellar visitors can preserve chemical accents from their birthplaces. Ratios of heavy to light hydrogen in water, the mix of carbon and nitrogen compounds, those are fingerprints that say, I formed where it was this cold and this rich in certain elements. If 3i Atlas keeps its stuff bottled until it gets close enough for sensitive instruments, we could add a new dot to the map of how different stellar neighborhoods flavor their ice. If all this sounds like we're standing on a dock as a ship slides past in fog, that's exactly right. You can learn a lot from how bright the lantern is, how the wake ripples, and whether you smell diesel or wood smoke, even if you never set foot on deck. We've gotten good at that game because we have to. If you're wondering why we don't just go look, there are indeed mission concepts that study how to intercept interstellar visitors. The trick is timing. You need a spacecraft ready to launch fast, with propulsion that can hustle, and the right camera kit to survive a high-speed flyby. It's not science fiction. It's just expensive and tight. To pay off a direct taste of stuff from another star belongs in the history-making bucket. Whether that happens for Atlas depends on windows and wallets more than wishes. Let's circle back to the rumor mill. The words probe and watcher stir the pot, so let's be precise about levels of claim. It's sensible to ask whether some interstellar objects could be artificial because we exist and we've already sent our own hardware on escape paths. Voyager and Pioneer are leaving the neighborhood right now with plaques and golden records and the whole human optimist package. If someone else got a head start by 1,000,000 years, it's not crazy to picture quiet scouts disguised as ordinary debris. But that picture is a story until the data demand it. An old-school comet scientist I like for his bluntness said, nature is weird enough to beat your best conspiracy 9 times out of 10. If we end up in that 10th slot, we'll change the label with a smile. Until then, the honest posture is curiosity plus restraint. There's also the question of why some of us want it to be more. Partly it's the itch left by Aoumuamua, which refused to fit the template and made everyone pick a favorite explanation, like choosing teams for a pickup game. Partly, it's the feeling that our instruments have finally gotten good enough to catch something extraordinary in the act. And partly, and this is the bar table truth, it's fun to imagine company in the dark. That doesn't mean we should bend the facts to fit the story. It means we should tell the story that the facts can carry, then stop, breathe, and wait for the next facts. So here's where we stand at this point in the night. We've got a confirmed interstellar visitor on a clean flyby, inbound fast, taking a path that looks convenient for our telescopes and rich in places to sample solar system environments. It's big enough to study in detail, but not so big it hogs the sky. Its surface acts like dark, dusty stuff. Its insides are likely a mix of ice and organics, the same building blocks that peppered our early Earth. It's been quieter than some expected on the way in, and that quiet is interesting, but not yet traumatic. Upcoming dates closest to the sun, at a friendlier phase for our best instruments. Then the long, fading exit will add the meat to the bones. Patience is a kind of detector, a mission planner told me once. That line didn't land until I watched cases like this. One last practical thing, because the internet lives on absolutes. If you hear definitely artificial or definitely boring, treat it like a loud opinion in a quiet library. The universe rewards people who can hold two ideas at once. That something could be ordinary and still worth our full attention. And that something could be extraordinary without needing us to leap there first. Tonight, we're taking the middle seat. We'll learn the object's habits, watch how it handles the sun's heat, listen for the chemical voices in its light, and keep an eye on its steering to see if gravity is the only hand on the wheel. That's not fence sitting. That's how you keep from falling off both sides. If 3 IATLAs ends up doing the normal comet thing, hissing gently near perihelion, shedding a little dust, showing water and simple carbon gases, we'll get priceless data about how other star systems season their ice. If it stays buttoned up, or if it moves in ways that whisper something else, then the conversation changes, and fair enough. Either way, we learn. Either way, it earns its place in the scrapbook right next to Oumuamu's stubbornness and Borisov's textbook tale. And either way, we'll stick with the same 3 labels for everything we say about it. What we know, what we think, and what we're daydreaming about while we wait for the next image to download. So let's take that knows the bus schedule feeling and actually kick the tires. Path through a solar system isn't the vibe. It's a combination of speed, angle, and timing. 31ATLAS is coming in fast on a retrograde track, meaning it's going the wrong way around our cosmic roundabout, and the tilt of its lane, the inclination, is steep enough that it stays in view for long, stretches instead of ducking behind the sun for months. Fact, retrograde plus high tilt is perfectly normal for a visitor that didn't form here. It doesn't care how our planets circulate. Fact, with a handful of nightly positions you can pin down a trajectory well enough to forecast where it'll be many weeks from now, because gravity is the most boring, dependable bouncer in the universe. Hypothesis, the specific geometry close enough to let Mars-based and Earth-based gear get a good look, close enough later to drift through Jupiter's turf looks unusually neat. Speculation, if you were designing a flyby to sample a system without swinging dangerously close to anything, you might pick a route a lot like this. That's the itch everyone's scratching. Before we serve ourselves a big plate of meaning, it helps to remember how often unlikely happens just because there are so many rolls of the dice. In a city of 1 million people, someone wins the weirdest coincidence lottery every day. Space is a bigger city. We only notice the visitors whose routes make us notice. The quiet ones too far, too faint, too badly lit slide by without a headline. That's selection bias in jeans and sneakers. We point the cameras where there's something to point at, then marvel that the interesting things are interesting. A dynamical modeler put it to me in a way that stuck. The sky doesn't care about our eyebrows. Now, here's where the route becomes more than a party trick. A retrograde tilted pass means 3I ATLAS plows through the solar wind and the thin fog of interplanetary dust head-on. Think driving into a snowstorm instead of with it. That's great for sampling. As it warms, even a shy object tends to shed a whisper of gas or dust. Those grains and molecules get chewed by sunlight and magnetic fields and become little messengers our instruments can read. If you're trying to learn about our neighborhood without breaking to a stop, that head-on geometry is efficient. That's me connecting dots out loud. On the label, fact about the geometry, hypothesis about the sampling, speculation about intent. Which brings us to the uncomfortable star of our show, the quiet. Typical comets wake up far from the sun 4 astronomical units out, because even weak sunlight is enough to tease the most eager Isis. First responders are usually simple carbon-bearing molecules that glow in very specific colors when sunlit. That's how we hear them. When we split light with spectroscopy and see those colors pop, we say, okay, the freezer door is open. With 3I Atlas, the early reports have been, at best, a shrug, a bump in brightness here, a maybe, maybe not detection there, and a lot of careful phrases like consistent with, and no significant emission detected. That doesn't equal dead. Dusty crusts can seal in ice like the burnt top on a creme brulee. The heat has to crack it before the kitchen smells like sugar. Thermal lag, the delay between sun hitting and stuff responding, is a thing. So is chemistry. That's just different, because this object was cooked in a different stellar kitchen. As one spectroscopist told me, if it breathes, we'll hear it in the colors. We're still cupping a hand to our ear. The size question keeps hitchhiking through this conversation, because size changes what quiet means. A handful of football fields is one story. Several miles across is another. Big bodies hold heat differently. They can have layers, insulations, trapped pockets. A darker skin sheds light and heat in a way that hides what's going on underneath. Early albedo estimates, the measure of how much sunlight the surface reflects, lean dark, like charcoal, rather than fresh ice. That nudges our guess toward larger. But brightness is a two-variable riddle. Size times reflectivity. Swap either and the same glow means a different body. Every number belongs in pencil for now. If you're wondering what would really make astronomers sit up, it's not a dramatic tale. Tales are great TV, but they're normal. The eyebrow raisers are patterns in the motion that don't line up with gravity and sunlight alone. Oumuamua did that tiny non-gravitational nudge away from the sun with no obvious gas puffs to blame, which is why you still see people arguing about it 6 years later. With 3I Atlas, a measurable drift that screams, there's a push here, without a matching chemical signature, would be a bigger deal than any pretty fan of dust. Another eyebrow is rotation. Objects spin. If the spin rate changes in ways that don't match the little torques that jets of gas would produce, that's interesting. So is how it heats and cools. A pile of ice and dust has a certain thermal personality. If this one warms too quickly or stays warm too long, that's a clue that the structure or materials aren't the usual. None of that claims anything beyond the obvious. Odd behavior deserves extra questions. On the tourist route idea, there's a sober middle road between wow, deliberate, and random. Space agencies have drawn up plenty of hypothetical paths for our own future probes that swing by a terrestrial planet, loop through the inner system for power and calibration, and then taste the big planet's magnetosphere on the way out. Those are good scientist routes, not spy routes. If a natural object happens to thread something similar, it's not proof of a plan. It's a reminder that physics offers only so many efficient highways, and any traveler, natural or not, will get funneled onto the same ones. A mission designer I pestered about this shrugged and said, there are only a handful of good on-ramps. Don't be shocked to see traffic on them. There's also the not super romantic possibility that 3I Atlas is just an older, tougher version of Borisova Big, well-baked comet that formed around a different star, with a crust that's lousy at venting until it's practically in the sun's foyer. Different stars salt their disks with different element mixes. The recipe for ice and organic gunk changes a little from neighborhood to neighborhood. That shows up in subtle ways ratios of heavy to light hydrogen in water, the balance of carbon compounds that we can read if and when the object finally exhales. If it does the normal comet song at close-range water vapor, simple carbon gases, a slow brightening that matches the sunlight curve, you'll watch a lot of dramatic headlines quietly melt into, well, that was educational, and the real science will get better, not worse. Ordinary isn't an insult in astronomy. It's the control group you use to learn what weird actually means. If, on the other hand, it stays locked up at distances where even shy comets usually wake, if perihelion comes and goes, and the spectrum keeps saying nope, that's when the temperature in the conference rooms goes up a notch. Then we're back in Oumuamua country, where you have to explain motion without gas, heat without the right colors, surface behavior that doesn't match the library. Even then, you can build natural explanations. Exotic ices that evaporate invisibly, mechanical structures like fractal fluff that react strangely to sunlight, crust chemistries that defy our solar system biased expectations. You can also responsibly leave a box on the table labeled technology and write, in small print, requires evidence we don't have. That's not coy, that's adult. Meanwhile, there's the logistics game. You can't intercept a thing like this with hope and duct tape. You need a spacecraft ready to sprint and instruments that won't fry during a high-speed pass. People have drawn those up for years, think. Rapid response comet chaser on steroids. But money and timing are the real bosses. Most likely, 3i Atlas will be another masterclass in remote sensing. We'll read its light, track its wobble, maybe ping it with radar if geometry cooperates, and stitch a story from 1,000 tiny clues. That's fine. We've built whole histories from less. Paleontologists make dinosaurs from teeth. Astronomers make worlds from photons. Let me add one tiny human note, because the internet loves to yank the steering wheel. You're allowed to want this to be special, and still insist on good evidence. You're allowed to root for ordinary but ancient, because a time capsule from another star is already the coolest thing your 8th grade self could imagine. And you're allowed to laugh at the way grown scientists argue like sports fans, and then buy each other coffee. 5 minutes later, a radio astronomer I adore summed it up perfectly. We don't like coincidences. The sky doesn't care. That's the energy we need, curious, patient, slightly caffeinated. So we keep watching the dot. We let gravity do its thing and see whether anything else joins the party. We listen for those chemical voices in the spectrum. We track the spin like a DJ eyeing the turntable, and we compare every twitch to what a big, dark, crusty interstellar snowball ought to do. If it acts like a rock, cool, we've learned how another star flavors its ice. If it doesn't, cooler, we've learned that our tidy categories still have holes. And maybe, just maybe, there's company in the dark that prefers to whisper. Either way, the fun part is ahead, not behind. Okay, pull the napkin back over. We've sketched the route. Now let's sketch the thing itself, which is a hilariously hard problem when your thing is a dim dot that politely refuses to resolve into anything more. The trick we use is brightness over time, what astronomers call a light curve, which is just a fancy way of saying we watch how the dot flickers as it spins. If a potato-shaped rock rotates, the broad side reflects more sunlight than the skinny side, so the brightness rises and falls like a tiny heartbeat. From the rhythm, you can guess the spin period. From the size of the rise and fall, you can guess how stretched the object is. Fact: this method works annoyingly well for asteroids and comets we've watched for decades. Hypothesis: 3IA TLA says heartbeat looks modest, which hints at a shape that's closer to lumpy sphere than cosmic toothpick. Speculation: that fits a big, crusty, snowball-style object, not a wafer-thin sail or a polished needle cool if true, but still in pencil. Light curves aren't just geometry gossip. They're thermometers in disguise. A surface with fluffy dust cools fast. A tighter, darker crust holds heat longer. Imagine two sidewalks at sunset, one asphalt, one concrete, and you're barefoot. You learn quick which one was darker. We do the same with 3-eye atlas by comparing its brightness at different wavelengths, meaning different colors of light, including the ones our eyes can't see. Infrared is the key because warm things glow there. Fact: darker surfaces, low albedo. Think 0.03 to 0.08 reflectivity. Tend to heat up and re-radiate in infrared more than shiny ice. Hypothesis: early hints lean dark, so we're probably dealing with a surface more like charcoal than snow. Speculation: a dark rind makes the object look smaller than it is, so size estimates inch upward unless you correct for that. You can see how one uncertain number leans its elbow on the next and the next, like a barstool chain reaction. Why not just bounce radar off it and be done? Because radar is needy. You want the object close and the geometry right, so the signal hits and returns with enough strength to matter. For a hyperfast interstellar visitor on the far side of the sun at the juicy moment, that's asking for a lot. If we do get radar later, a strong return would scream denser, tougher surface, while a whisper might mean fluffy dust or just too far, too small. Sorry. That ambiguity is the theme of this whole gig. We're eavesdropping through a keyhole. Composition is where the fun starts. When sunlight passes through a cloud of gas around a comet, the coma, it gets chewed into rainbow fingerprints by whatever molecules are there. Water splits and remixes. Carbon-bearing stuff fluoresces in very specific ways. Cyanogen, diatomic carbon, simple organics. These are the early chatterboxes. Fact: with spectrographs, you can pick out those fingerprints, even when the object is faint, as long as the molecules are actually in the air. Hypothesis: 3-eye atlas hasn't been particularly chatty at long range, which could mean it's still locked up, or the first gases are the hard-to-hear kind, or the crust is smothering vents. Speculation: if it's truly quiet right up close to the sun, call it around 1 to 2 astronomical units. 1 astronomical unit is roughly 150 million kilometers, or 93 million miles. That's weird enough to spark a mini food fight in the community. Here's a detour worth taking. Not all ices are equal. Water ice is obvious, but carbon monoxide and carbon dioxide ices evaporate at different temperatures, like different alcohols flashing off a pan. The blend you get depends on where the object formed and how it was baked later. Stars themselves salt their neighborhoods differently. Some are richer in heavy elements, some poorer. We can read those differences through isotopes, same element, different weight. Hydrogen has a heavier sibling called deuterium. The ratio of deuterium to hydrogen in water is like a return address. Fact: interstellar visitors we've seen before didn't line up perfectly with our solar system's ratios. Hypothesis: if 3-eye atlas exhales, we'll measure those ratios and tell whether it grew up in a colder pantry or a warmer one, or around a star that had more metals to share. Speculation: a wildly off-the-charts ratio would be the sort of raise your hand moment that gets telescopes rescheduled overnight. What about that artificial camouflage idea? File it under fun to imagine, requires proof. If someone wanted to pass a probe through without spooking the locals, dressing it in real ice and organics would be a smart disguise. You could even imagine engineered materials that sublimate, cleanly no telltale molecules, so the coma looks boring or never forms. But that's a tall claim, and the honest stance is simple. Until we see behavior that natural chemistry really struggles to explain. Non-gravitational pushes without any thermal or chemical cause. Heat patterns that scream machined. Internal reflections that look like cavities or trusses. We stick with rock and ice stories. You can keep the what-if box open on the table as long as the label says needs extraordinary evidence. Spin adds another clue. Jets of gas act like tiny thrusters, nudging the rotation. If the spin speeds up or slows down in ways that match sunlit patches turning on and off, you can map where the vents are. If the spin changes without any vents or changes opposite to what vents would do, that's a puzzle piece that doesn't fit. Fact: these torques are small, measured over days to weeks, and you need annoyingly precise timing. Hypothesis: if 3IATLA-S is big and crusted, any jets might be localized and intermittent, so the spin changes could be subtle and late. Speculation: a steady, stubborn spin through perihelion would feed the sealed rind picture. A jumpy spin with no matching gas signatures would feed other conversations. There's also the headwind angle we talked about earlier. A retrograde traveler slams into the solar wind, the stream of charged particles flowing off the sun like a runner into the breeze. That can charge dust differently and change how grains peel off. It can also mess with how a coma looks, bending it into odd shapes. Fact: magnetospheres, the magnetic bubbles around planets, add more chaos, especially Jupiter's giant one. Hypothesis: if 3IATLA-S wanders through that environment, any shed material might get trapped or stretched in ways that make the coma look wrong, which is to say, different from our library photos. Speculation: folks will argue about whether wrong looking is physics being playful or something stranger. Place your bets, but keep them small. One quiet superpower in all of this is patience. If you track color again, that's spectroscopy night after night. You can see trends even when single-night data look bland. A gentle increase in water vapor lines, then a plateau, then a late bloom of carbon compounds. That's a narrative. Fact: comets often have layered ices, so heating peels them like an onion. Hypothesis: a big interstellar onion might have layers we don't usually see here, so the order of smells could surprise us. Speculation: if the order is upside down, say, complex organics pop before water, as that'll send theorists back to their whiteboards with new curses to invent. And yes, the how big is big question comes back for an encore, because it feeds safety questions too. Don't panic, this isn't a doomsday scenario. A hyperbolic orbit means it isn't staying. But closest approach distance still matters for planning, and for how bright and noisy it gets in our instruments. Fact: every uptick in brightness near the sun can be explained by either its venting or we lowballed the size. Hypothesis: if we keep needing to resize it upward to explain the glow without gas, we'll accept the larger body, darker skin picture grudgingly, but happily. Speculation: a truly massive body that refuses to vent would become the poster child for alien recipes make alien crusts. A quick quote to keep us honest. A comet specialist once told me, most mysteries turn out to be bad calibration. It's not cynical. It's a reminder that our gear, our models, even our eyes have personalities. We cross-check instruments, share raw data, and let rivals take their best shots, because that's how you sand the rough edges off, an exciting result. If a weird feature survives that gauntlet, it's probably real. And if it doesn't, you still learn something about your tools. That science is housework no glory, but the place smells better. So where are we, beer-ringed napkin and all? We've got a dark-skinned visitor, probably chunky rather than needle-thin, on a route that's great for sampling and better for arguments. It's quiet so far in the bands where early bird molecules usually sing, which could mean crust, chemistry, timing, or if it stays quiet, something we don't have on our shelf yet. The next checkpoints are simple to say, harder to do. Catch the heartbeat cleanly. Watch for any drift that gravity can't explain. Hunt for the first whiff of gas and keep an eye on the heat. If our cosmic tourist finally orders a drink at the bar and starts talking water, CARBON, the usual, then we clink glasses and dig into a very old recipe from a very distant kitchen. If it keeps staring back in silence as the sun gets uncomfortably close, well, that's when even the quiet folks at the end of the table lean in. Slide the napkin back into the spotlight, and let's talk about the path, the part that makes even calm people drum their fingers. Everyone agrees 3i Atlas is on a hyperbolic track, which is just the polite way of saying in from the dark, out to the dark, no return ticket. The oddness lives in the details of how it threads the pins on the way through. Think of the solar system as a bowling alley where the lanes are tilted, the pins are moving, and the ball comes in from the parking lot at an angle nobody practices. Fact, you can compute that lane precisely from a handful of very careful sky positions and times. Hypothesis, when you do, you notice the ball isn't just skimming the gutter and leaving. It's passing by a few pins at suspiciously photogenic distances. Speculation, if you wanted to make the tour and not get noticed, that's pretty much the tour you'd take. Quick definitions, no quiz. Perihelion is the closest point to the sun. Inclination is how tilted the path is compared to Earth's track. Retrograde means it's moving against the traffic, like a salmon in a freeway. 31ATLAS checks all three boxes in ways that are fine individually and eyebrow-raising as a set. Retrograde motion isn't rare for interstellar visitors. They arrive from everywhere. But here's the barstool condensation of the math. The inclination is tilted just enough that the object stays conveniently observable from Earth for much of its ride. The perihelion distance is close enough to warm it without frying it, and the moments when it's awkward for Earth to watch line up with times when spacecraft at other vantage points, Mars orbit, solar observatories, can do the seeing. A dynamicist friend summed it up to me as, if it's a coincidence, it's a very considerate one. Now, before we start printing bumper stickers, take a breath and remember how brains work. We're wired to spot faces in toast and conspiracies in traffic. In science speak, that's selection bias and apophenia, the habit of noticing the weird ones and then backfilling a story. Fact, surveys are way more likely to flag interstellar, objects that pass where our telescopes are most sensitive and our skies are clear. Hypothesis, some fraction of, wow, what are the odds, is just us paying attention when the universe finally tosses us a pitch we can actually hit. Speculation, if we ran the tape of random interstellar flybys for 1,000,000 years, we'd eventually get a route that looks choreographed. We just happen to be here for this one. Still, the route has flavor. Early on it brushes the orbital neighborhood of Mars, close enough that the instruments orbiting the red planet can potentially sniff any gases if they show up. The closest approach to the sun happens at a distance where water ice usually wakes up, and it does so when Earth is kind of looking the other way behind solar glare, which is annoying for us and perfect if you'd rather conduct business out of sight. Months later, the outbound leg saunters through Jupiter's magnetic bubble, the biggest in the neighborhood, which is like walking past the world's largest neon sign that says, "Charged particles sampled here." Fact, those are real waypoints with dates on a calendar and ranges in millions of miles or kilometers. Hypothesis, that sequence is excellent for science, whether you're made of meat and curiosity or metal and intentions. Speculation, it's also the exact sort of itinerary a cautious tourist with a very old map might choose just enough to learn, not enough to bump elbows. Gravitational assists are the same person's explanation for fancy paths. You can steal a little energy and change direction by falling past a planet, a trick we use all the time with our spacecraft. But a good billiards player will tell you setup matters. To hit the second shot, you had to place the cue ball right on the first. Fact, the positions of the planets are not secrets. The geometry is fixed years in advance. Hypothesis, an object launched long ago from far away could, in principle, be aimed to pass the pins in style without doing anything fancy on the way. Speculation, if it does anything that looks like a mid-course tweak, tiny nudges that gravity alone can't account for, that's when the quiet table at the back of the bar stops talking. So what would a tweak look like when your probe, if that's even the right word, is clothed in rock and ice? Comets sometimes get little rocket pushes from jets of gas. That's bog standard physics. If 3IATLAS starts to deviate from the gravity-only prediction, the first thing you do is go hunting for the culprits. Visible jets, a puff of water or carbon compounds, a coma brightening in step with the push. Fact, we've measured those tiny accelerations before in homegrown comets, and they line up when gas vents face the sun. Hypothesis, if the push arrives and the chemistry doesn't, you've got some explaining to do: special ices, weird crust, or bad calibration. Speculation, if the push arrives, the chemistry doesn't, and the timing smells deliberate. Say, always when the object is behind the sun for Earth, but visible to instruments elsewhere. That's not nothing. A small quote from a very sensible comet person. Nature is allowed to be weird. She just has to be consistently weird. That's the North Star here. If the weirdness repeats with the rhythm of heating and cooling and the geometry of sunlight, you can fit it into the natural playbook. If the weirdness clusters around convenient blind spots, you circle it in red, but keep your pen in your pocket. There's also the "what would you want to see if you were the one watching us" game, which sounds like late-night nonsense until you realize it's just planning an observation campaign with extra steps. You'd want line of sight across Earth's atmosphere to read the mix of gases. You'd want passes through the solar wind upwind and downwind to sample the charged stuff. You'd want a taste of a terrestrial planet's environment. Hello, Mars. And you'd want to feel the bite of a giant's magnetosphere. Hi, Jupiter. Fact, 3IATLAS's lane touches all those environments in a single pass. Hypothesis, you can check those boxes accidentally with a lucky throw. Speculation, you don't get extra points for doing it quietly unless quiet mattered to you. None of this makes it a spy. It just raises the stakes on the next measurements. If gravity is the only hand on its shoulder, the path we've computed should keep fitting as we add data. If not, the residuals, the tiny differences between prediction and reality, will begin to dance. We'll try to blame jets, and we should, because that's how you keep your head. We'll model sunlight pressure, the faint shove from photons, and we'll stitch together radar, optical, and infrared, so we're not fooled by one instrument's mood. If, after all that laundry, the dance persists, then we can start asking the louder questions with a straight face. A word about probability before we're drowned in it. When you hear 1 in 20,000, it does not mean the universe rolled a die labeled 1 through 20,000 and chose this outcome just to wink at you. It means, under the assumptions of the model, and given our detection biases, roots the suspicious are expected rarely. Fact, rare things happen all the time when you're looking at a sky full of possibilities. Hypothesis, we're especially primed to notice them now because we've had only a few interstellar guests we could study at all. Speculation, as the census grows, today's eyebrow-raising might turn into tomorrow's shrug. Or the opposite, we might find the odd paths cluster in ways that demand a new story. Why is perihelion behind the sun from Earth? Because orbital geometry is a prankster. Sometimes the clock hands just line up that way. It's inconvenient, not sinister. Thankfully, we don't only have eyeballs on Earth. Solar monitors with coronagraphs cameras that block the sun's face to see the faint stuff around it can still watch the show. Mars orbiters get angles we don't. Timing that looks like a magic trick from one seat is just Tuesday from another. And if you're wondering about safety perfectly reasonable, here's the calm truth. Hyperbolic means it's not captured. It's not looping back on us later. The distances we're talking about at closest range to Earth are big in human terms, tens to hundreds of millions of kilometers, and baked into the numbers early. The only thing 3IATLA as threatens is our peace of mind and our sleep schedules. So yeah, the path is interesting. Interesting enough to draw polite murmurs from people who don't murmur easily. But a path, no matter how photogenic, isn't proof of anything beyond a path. The universe is capable of massive coincidence, and we're capable of making coincidence look like choreography. The way out of that trap is the same as always. Keep measuring, keep predicting, keep checking the gaps between the two, and don't fall in love with any single explanation. Or, to steal a line I like, don't marry your hypothesis. Date it until the data ghost you or they don't. Coming up, we put our noses even closer to the glass. The first real chance for outgassing as the heat turns up, the chase for any non-gravitational nudges, and the awkward, fascinating leg through Jupiter's magnetic weather. If the story is natural, the plot points will land where we expect. If it's not, we won't need poetry to notice. Okay, smell test time. When a big, cold thing drifts toward the sun, it should start to breathe. Comets breathe by warming up and letting their ices turn straight into gas, which makes that fuzzy halo called a coma and sometimes a tail. You don't need to see a Hollywood plume. A whisper will do. We sniff for it with spectral rainbows broken into thin combs where certain teeth, wavelengths, go missing or glow. Fact: different ices wake up at different distances. Carbon monoxide and nitrogen can start leaking as far out as 5 to 6 astronomical units, astronomical unit. Carbon dioxide usually closer in, and plain old water tends to really get going inside approximately 2 to 3 astronomical units, with lots of wiggle room for surface crusts and spin. Hypothesis: by the time a 7-mile wide lump approximately equals 11 kilometers, like 3I ATLAs, slides into the inner system, we ought to catch at least a yawn. Speculation: if we don't, either it's playing possum, or we're looking at a recipe we haven't tasted before. Let's define the usual suspects, so we're on the same page. A coma is the fuzzy atmosphere that forms around an active comet. It's just gas and dust slowly escaping. Non-gravitational acceleration is the tiny shove a comet gets when those gas jets act like thrusters. Tiny here means very tiny, think millionths of a meter per second squared small, enough that you need weeks of careful tracking to spot the difference from pure gravity. And a spectrum is basically a chemical lie detector. Water, coal, methane, and more exotic organics each leave their fingerprints. Fact: there are classic comet tells like CN cyanogen and C, a carbon pair, that light up easily in sunlight. Hypothesis: if those lines stay dark even as the heat turns up, we're in unusual territory. Speculation: unusual isn't the same as artificial, but it does make you order another round and keep watching. Here's the awkward bit. Early peaks at 3 IATLAs have leaned more quiet boulder than hissing kettle. That doesn't prove anything except patience is a virtue. The first gas to show can be CO or CO, and depending on surface insulation, think of a blanket of cooked dust. Baked into a crust, those vapors can be trapped until cracks form. A big body with low reflectivity, lots of interplanetary gunk, albedo a few percent, soaks up sunlight, but its thermal inertia means it warms like a slow oven, not a frying pan. Fact: comets from our own backyard often carry a hardened lag deposit from past heating that mutes activity. Hypothesis: an interstellar wanderer could build a similar crust from cosmic rays and micrometeorite sandblasting over millions of years, turning the top millimeters into a weathered shell. Speculation: that shell could be thick enough to delay the show well inside 2 astronomical units, and then everything happens at once like a popped balloon. Now, what would count as a real curveball? If 3IA TLA S starts to feel a steady push that can't be hung on sunlight, too massive, or on symmetric outgassing we can actually see, eyebrows go up. Radiation pressure, the gentle nudge from photons, only matters if your area to mass ratio is huge, like a sail or a leaf. For a mountain of ice and rock weighing on the order of 1 trillion kilograms, give or take, density uncertain, sunlight is a poem, not a motor. Fact: in practice, when comets drift off the gravity-only track, we almost always find jets or a coma brightening in step with the push. Hypothesis. If the push shows up without the breath, we'll have to reach for stranger ices, weird thermal plumbing, or admit our measurements need cleaning. Speculation. If the push times itself to moments when Earth can't see, say, during a sun-hugging turn, but other vantage points can, you don't need to be paranoid to call that interesting. Let's talk chemistry as a map to birthplace. One of the neat party tricks here is the deuterium to hydrogen ratio in water, a tiny fraction of heavy hydrogen mixed into the ice. Different stellar nurseries, different ratios. It's like tasting the soil in a wine. We can also peek at carbon and nitrogen isotopes. Ice remembers the nursery. As one planetary chemist likes to say, and 3I Atlas is big enough that its interior should be museum-grade pristine, shielded from space, weathering by its own bulk. Fact. If the isotopic mix lands outside anything we've cataloged in our solar system, that's a fingerprint of faraway origins, not a smoking gun of engineering. Hypothesis. A star system older or metal-richer than ours could easily cook up different balances of volatiles and organics. Speculation. If the wine tastes not only foreign, but deliberately blended, say, outgassing that shows only the most boring, ubiquitous gases and aggressively hides the rest, that's camouflage territory. Still not proof, but you see why observers would lean closer. There's also a practical thing about how activity starts. Comets don't boil like kettles, they localize. A few sun-facing patches break first, vents open along fractures, and if the body is spinning, the jets sweep around like lawn sprinklers. That means the little thrusts are not just small. They're uneven, tied to time of day and season on the comet. Fact. We can model those patterns and see if the wiggles match natural sunlight geometry. Hypothesis. A consistent mismatch, say, thrusts that always coincide with specific geometry relative to Earth or spacecraft, rather than the Sun, would be hard to square with nature. Speculation. In that case, you could imagine controlled venting open the valve when the teacher isn't looking, shut it when she is. It sounds cheeky, but that's exactly the kind of timing games engineers play with our own. Deep space probes when we're dodging radio interference or maximizing science time. You'll also hear about dust or the lack of it. A dusty coma scatters sunlight and makes the showy tails. A dust-poor outflow is harder to see. Some ices, especially CO and N, can sublimate cleanly, lofting fewer grains. Fact. A dust-poor, gas-rich coma would hide better from casual telescopes, while still giving infrared instruments a decent whiff. Hypothesis. If 3I-ATLAS prefers dustless outgassing, that could be pure composition. Speculation. It could also be deliberate. Less dust means less glow, less chance to tip off a nervous species glued to its skies. A comet dynamicist I like has a one-liner for this moment. If it's a rock, it'll act like rocks do. If it's a plan, it'll act like a plan. Rocks don't check schedules, plans do. So what's on the calendar? The heating curve between roughly 2O and perihelion is where water takes the wheel. We'd expect a coma to thicken, maybe a tail to show, and the tracking residuals, the tiny differences between predicted and actual positions, to wobble in sync with the object's day. Fact. Those measurements come with uncertainties, often quoted in arcseconds and milliseconds that translate to hundreds or thousands of kilometers out in space. Hypothesis. If the residuals shrink as we feed in realistic jet models, we'll shrug, high-five the physics, and file 3I Atlas under large, instructive comet from out of town. Speculation. If the residuals grow, and especially if they cluster around convenient times and angles, the case for something less boring gets a spine. What about the why now itch? We're better at finding these things. Surveys cover huge chunks of sky every few nights. Software spots the movers. Follow-up teams pounce. Fact. With wider eyes and faster alerts, we'll catch more interstellar passers-by, including the oddballs. Hypothesis. As the sample grows, today's weirdo might slide into a bell curve we don't yet know. Speculation, or we'll see subpopulations quiet bruisers like 3I ATLAS, flashy sprinters like the one we nicknamed before, and a handful that don't fit either family. And that's when you start asking whether interstellar object is a category or a cover. I want one more guardrail on the table. Occam's razor, the boring friend we all need. The simplest explanation that fits the data gets first dibs. A crust that delays venting is simpler than a cloaked machine. An odd isotopic ratio is simpler than designer ice. Extraordinary claims need receipts, as an observer told me over coffee. Fact, nature loves to surprise us, but she rarely cheats. Hypothesis, 3IATLAs is going to wake up in some flavor of normal, and we'll learn a ton from exactly how. Speculation, if it stubbornly refuses to be normal, even after we've shaved away every dull explanation, we'll have a better, cleaner conversation about the exciting ones. In the meantime, the plan is simple and very human. Watch, measure, compare, repeat. Infrared eyes to catch warm gases. Ultraviolet sniffers to catch the fragile stuff. Photometry to track the heartbeat as it spins. And 1,000 small arguments about whether a bump in a plot is a jet, a glitch, or the universe winking. If it's a rock, it'll act like rocks do. If it's a plan, well, plans leave patterns. Let's talk route, because 3I Atlas isn't just inbound, it's taking what looks suspiciously like the scenic drive. Fact, it's on a retrograde path, which just means it's swimming upstream against the way the planets go around the sun. That alone isn't weird for an interstellar stray. Visitors can fall in from any angle. The eyebrow raise comes from the geometry. The orbit is tilted steeply picture, a hula hoop tossed so it stands almost upright instead of flat. And that tilt happens to keep the object nicely placed for long stretches of observation from Earth. Hypothesis, that alignment is luck amplified by our improved surveys. We see what we can see. Speculation, if you wanted to give skywatchers continuous views while avoiding awkward close passes, you could hardly do better. As one orbital dynamicist likes to deadpan, gravity doesn't care about our stories. Fair enough. But some stories do seem to care about gravity. As it threads inward, the pit stops red like a checklist. There's a respectful slip past Mars, close enough that orbiters could get a decent look if the timing and illumination cooperate. Perihelion closest approach to the sun lands, not dangerously close, but warm enough to stress the surface and wake any buried ices. Then, on the way out, it drifts to a sweet, not too sweet distance from Earth, the kind that makes space telescopes hum. And later, there's the big dog, a pass inside Jupiter's magnetic bubble. A magnetosphere is a planet's force field, the region where its magnetic field shoves solar wind around. It's stuffed with charged particles and dust, a natural sampler platter for anything drifting through. Fact, flybys happen. Space is full of moving targets, and gravity is the ultimate travel agent. Hypothesis, most interstellar objects won't string together this many photogenic moments. Speculation, if you were a secretive tourist, you'd hit the same landmarks. A word about odds, because unlikely can become a magic trick if we're sloppy. People run Monte Carlo simulations, lots of fake universes rolled forward, to ask how often a path like this pops up by accident. Fact, the answer depends painfully on what counts as like this. Change a tolerance here or there, and your one in many becomes a shrug. Hypothesis, with our current sky coverage, we're biased to notice interstellar visitors whose paths are convenient for us, and blind to the ones that skim the outer dark and leave no trace. Speculation, even after you correct for that, this itinerary won't look common. Rare but natural is still on the table, but it has to fight for the mic. A mission designer I know has a motto taped to their monitor: Never attribute to aliens what a good trajectory engineer can do with patience. Inclination is another piece folks get animated about. If you lay a sheet of paper flat to be the planet's plane, and then jab a pencil through at a steep slant, that pencil is 3i ATLAS. Fact, a steep retrograde inclination lets it plow through more of the sun's wind and the dust drifting in the inner system than a gentle prograde lane would. That's chemistry heaven for scientists, because different regions carry different flavors of tiny particles and magnetic fingerprints. Hypothesis. A natural origin doesn't care about sampling. It just ends up where it ends up. Speculation. A reconnaissance route would care very much. You choose angles that let your instruments taste as many environments as possible in one pass, and a retrograde tilt is the buffet line. Now, the sun-hugging interlude. Perihelion mechanics are reliable. You speed up, you heat up, and if you're a normal comet, you start leaking gas. We already talked about how that leak can be shy or flamboyant. Here, the timing matters as much as the chemistry. Fact, when an object tucks closer to the sun from our viewpoint, Earth-based telescopes lose track in the glare for a while, and only spacecraft in the right spots can keep watch. Hypothesis. A natural rock doesn't pick its moment. It takes what celestial mechanics give it. Speculation. An engineered probe would love a privacy curtain. Do your loud operations when your nosiest neighbor is squinting, then glide back into view looking composed. Trajectories don't have intent, a professor told me, but operators do. It's cheeky. It's also true. The Earth pass on the outbound leg is a quieter kind of interesting. You don't want to spook anybody by barreling through the neighborhood, but you do want to be close enough for high-quality data, both ours and yours. Fact, a distance on the order of a couple 100 million kilometers is observational candy for space telescopes bright enough for detailed spectra, safe enough that nobody drafts planetary defense memos. Hypothesis. Pick a random interstellar arrival and you'll more likely get an awkward geometry that's either too far for detail or too close for comfort. Speculation. The way 3i Atlas threads that needle feels. Practiced. Again, no smoking gun, just that familiar bar stool. Huh. Then there's Jupiter. If you haven't met a gas giant's magnetosphere, imagine an invisible storm system the size of a star, humming with radiation and trapped dust, stretching out behind the planet like a windsock millions of kilometers long. Fact. A pass through that environment will sandblast you with charged particles and bend your path in a way that sharpens our mass estimate, because gravity never lies. Hypothesis. Even a natural object's surface gets its paint tested their fragile crusts crack. Fresh ice shows activity spikes or stutters. Speculation. If you're carrying sensors, that's the mother lode plasma, fields, grains, the whole weather report of a planet that's been shaping our solar system since day one. A Jovian specialist once joked to me, if I were an alien doing one lap, I'd eat at Jupiter. Before anyone prints t-shirts, there's the caution flag, the lottery winner effect. We notice the outlier because it's flashy and forget the crowd of losers who never get airtime. Fact. Interstellar objects we don't detect could outnumber the ones we do by orders of magnitude. Hypothesis. Our sample is so small that building a personality profile for these visitors is like judging a city by 2 cab rides and a coffee. Speculation. 5, 10, 20 more detections and 3i Atlas may look like the quirky cousin, not the mastermind. Until then, the fair thing is to keep both narratives in play and let the physics do the culling. There's also the humility piece. Navigation is unforgiving, whether you're a comet or a captain. Tiny early nudges become big late differences. Fact. If we had exact pre-solar system data, which we don't, we could rewind 31ATLAS's path and see whether some long ago planetary encounter in another system tossed it this way with exactly the energy and aim we see now. Hypothesis. A close pass by a heavy planet or a binary star can sculpt a path that looks uncanny ages later. Speculation. Advanced operators could sculpt it on purpose far more cleanly. Using the same gravity assists our own probes use, just with patience beyond our funding cycles. Given time, gravity is the best fuel, as one mission planner likes to say. So where does that leave us at the bar? Elbows on the table, watching the napkin map. Somewhere productive. Actually, fact, the itinerary is rare and delicious for science. Hypothesis. Rare doesn't mean rigged. It means we got lucky, and we should squeeze every drop of data from the luck. Speculation. If someone else squeezed first, if this is a plan, not a rock, we'll know it by footprints, not vibes. Course tweaks that don't match sunlight or jets. Emissions that show up when we shouldn't be able to see them. Measurements that cluster around convenience rather than physics. Plans leave patterns. Rocks leave debris. For now, we sharpen the pencils and keep time. Mars for a polite nod. Sun for the heat test. Earth for the deep sniff. Jupiter for the gauntlet. If 3i Itulas is just a big, quiet traveler, the route will feel like a long, patient coincidence. If it's hiding something big, the coincidences will start to rhyme. As an old hand told me, the cosmos is weird, but it's rarely coy. We're about to find out which flavor of weird we've got. Okay, let's pour another round and tackle the question that keeps coming up in every late-night email thread. Where's the fuzz? A typical icy visitor that drifts inward, warms up, and starts shedding gas, throws on a coma, that soft glow of vapor and dust. Outgassing is just ice turning straight into gas-no puddles in space, dragging dust into a hazy halo and sometimes a tail. We've all seen the textbook version. With 3IATLAS, the textbook is still open to the same page, but the margins are suspiciously clean. Fact, as an object approaches the sun, you expect certain ices to wake up at certain distances. Carbon monoxide and carbon dioxide are early risers. They can start lifting off even beyond 3 astronomical units, where 1O is the Earth-Sun distance. Water ice, the big player, usually gets lively closer in, roughly 2 astronomical units and inward, depending on crust, porosity, and how sunlight hits. Hypothesis. If 3I Atlas is built like a standard, cold storage comet ice and dust glued together like a cosmic snow cone its surface, should already be whispering to us in the spectra. Faint signatures around ultraviolet, invisible wavelengths for radicals like CN, cyanogen, and C, diatomic carbon, and infrared fingerprints for water and organics. Speculation. If those lines stay stubbornly quiet even as the thermometer climbs, either the skin is tougher than we thought, or somebody's playing with the dimmer switch. Let's demystify those squiggly lines for a second. Astronomers hunt emission bands, which are little neon signs molecules flash when sunlight excites them. CN has a strong band near 388 nanometers, bluish purple. C does the swan band thing in the green, near 516 nanometers. Break water with sunlight, and you get O at about 308 nanometers. Think of it like walking past restaurants. Each cuisine has an aroma. Your spectrograph nose can tell who's cooking even if the kitchen is down the block. So far, the usual aromas around 3I Atlas have been faint to non-existent, at least compared to what you'd expect for something this size. Fact, non-detection doesn't mean doesn't exist. It means below our current sniffers. Hypothesis. Geometry matters if jets point away, or if dust smothers the gas, lines can hide. Speculation. If the cook only turns on the stove when the health inspector is out to lunch, say, when the object dips too close to the sun for Earth telescopes to watch, you'd miss the sizzle by design. There's a perfectly boring explanation, and it's a good one. Crust. Sunlight bakes the top layer, sintering dust into a kind of armor. A few centimeters of this stuff can act like a potholder, keeping the heat from reaching the juicy ice below. Scientists talk about thermal skin depth, which is how deep a day-night or seasonal temperature swing can sneak in. On a slow-rotating lump with low thermal conductivity, that depth can be shallow. Fact, even a crust just a few fingers thick can delay outgassing by millions of kilometers of travel. Hypothesis: interstellar rays and micrometeoroids have spent eons toughening 3I a TLA's shell into a miserly lid. Speculation: somewhere under that lid are pressure cookers waiting for the first crack. If they blow, we'll see a sudden brightening and, with luck, those longed-for spectral aromas. Alternatively, the recipe could simply be weird. Interstellar doesn't mean like home but colder. It means different nursery, different pantry. If 3I Atlas grew up where oxygen and carbon ratios skewed, or where certain ices condensed in layers, the first gases off the surface might not be the ones we're used to. Fact, even within our own comet family, dust-to-gas ratios vary wildly. Some are dusty snowballs, some are snowy dust balls. Hypothesis: this one's on the dust-heavy end, so any gas gets trapped and refrozen locally, muffling the coma. Speculation: a composition flavored with exotic organics could sublimate in a hush, leaving us with a dark traveler that keeps its breath to itself until perihelion presses the issue. But couldn't it be outgassing invisibly? Great question. Sometimes the gas of choice is hard to catch. Hydrogen, for instance, is a ghost at optical wavelengths. If water breaks down and the hydrogen slips away quietly, your visible light spectrographs won't throw confetti. Infrared can help, but only when you're not fighting the sun's glare or Earth's own warm, noisy atmosphere. Fact, space telescopes beat ground ones for these whispers, but they get limited time and tricky geometry. Hypothesis: if 3I a TLA's times its warmest behavior for when it's tucked near the sun from our point of view, we'll need spacecraft parked just right solar observatories with coronagraphs that block the sun's disk to keep watch. Speculation: if somebody wanted privacy for a loud activity phase, that's exactly the curtain they'd choose to stand behind. There's also the stealth jet angle. A jet is just a vent. Gas shoots from a crack, and like a squirt gun, it can nudge the whole body, producing a tiny extra push astronomers can measure if they watch the path closely enough. With Oumuamua, that push caused drama because we couldn't see the jets that would explain it. With 3I ATLAS, the mass is so large that any comparable jet would have to be beefier to matter. Fact, non-gravitational accelerations scale with surface forces and total mass. Bigger mountain, smaller move for the same shove. Hypothesis: if we spot a consistent, sunlight-linked drift off the purely gravitational path, that's a tell for outgassing, even if the coma is shy. Speculation: if we spot course changes that don't match sunlight, timing, or sensible jet geometry, those aren't squirts. Those are steering. While we're in lab coat mode, a few numbers to frame expectations. A normal strong comet can lose hundreds of kilograms of material per second near 1 astronomical unit. A sleepy one might puff at a few kilograms per second or less. The difference to our sensors? Enormous. At a couple of U, a coma so thin you could walk through it without noticing can be below detection for ground telescopes, especially if the dust grains are big and don't reflect much light. Fact, 3I ATLA's surface appears very dark, meaning it's absorbing sunlight efficiently, but not reflecting much of it back to help us see. Hypothesis: big grains plus low albedo is the ninja outfit of Comet Kame. Speculation: the first clear signal might be thermal and infrared glow that spikes as buried. Pockets vent before the optical signatures catch up. There's a curveball we have to mention: outbursts. Some comets play polite, slowly brightening as the math predicts. Others bottle it up and then pop. Stress cracks, spinning changes, or pressure buildups can trigger a flash of bright dust and gas. Fact: rotation matters. A period of hours sets when the same patch of ground returns to sunlight and how heat leaks sideways. Hypothesis: if 3I Atlas is wobbling or speeding up slightly under asymmetric heating, Yorp effect is the fancy name cracks can propagate suddenly, turning the volume from 2 to 11 in minutes. Speculation: an engineered shell could be designed to tolerate or exploit that, venting at planned longitudes and local mornings. A natural one just hopes it doesn't split the wrong way. Could the spectra be faked? That's the sci-fi question, and we'll handle it with oven mitts. Fact: in principle, a surface layer can be salted with compounds that, when warmed, give off the expected comet smells on cue. We've done tiny cousins of that trick with spacecraft materials to control outgassing. Hypothesis: any deliberate mimicry would still have to square with timing, brightness, and the way sunlight angles change the show. Speculation: camouflage is cheap until you have to do it perfectly across wavelengths, distances, and months. Slip once, and the pattern which shows up when and how strongly betrays your hand. So how do we keep score without fooling ourselves? By watching everything at once. Track the spin rate for tiny changes. Gas escaping steals angular momentum. Watch the light curve to see if the bright and dark patches repeat cleanly or change as vents open. Compare spectra across ultraviolet, visible, and infrared so a late arriving line has context. Fact: physics is a tattletale. Processes couple together. Hypothesis: a natural object will show messy but sensible correlations. Heat up, vent some, spin a bit, settle down. Speculation: an unnatural one might show convenience correlations venting when hidden, quiescent when watched, accelerations that point to nowhere in particular. A veteran comet watcher summed it up to me with a line I keep coming back to: rocks are lazy storytellers. If 3I A's is just big and shy, the tail will be slow and consistent. Signatures will creep in as the heat soaks deeper, and our instruments will finally catch the breath around perihelion and beyond. If it isn't lazy, if it chooses its moments like a stage magician, we'll see the tells in the seams, the missing lines that should be there, the early ones that shouldn't, the timing that flatters geometry rather than obeys the stove. Either way, the next act writes itself. Perihelion is the hot seat. Outbound is the honesty test. A coma that arrives late but rings true would be the most comet-wide outcome in the world. A hush through the heat and a path that drifts in ways sunlight can't explain would move our bar talk from huh to okay. Now you have my attention. Let's talk about the path, because that's where 3I Atlas starts to feel less like a stranger strolling past our porch and more like someone who already knows which floorboards squeak. Any rock from out there, interstellar, just means it came from beyond our sun's family, can dive in from any angle. Most of our homegrown stuff orbits the sun in a flat band we call the ecliptic, like cars circling a racetrack. Visitors can come in above, below, sideways, even going the wrong way. Retrograde is the term for when it sails against traffic. On paper, that's all fine. Space doesn't care about our lanes. But when you plot 3I ATLAS across the months, the route looks unusually convenient. It's as if the cosmic GPS said, okay, skim near the inner planets for a look, tuck behind the sun during the noisy part, then cruise past the big gas giant's magnetic bubble for dessert. Fact: a hyperbolic orbit eccentricity greater than 1 is the calling card of a true interstellar visitor. It means the object isn't bound to the sun. It's on a one-time pass, in and out, goodbye. Fact: inclination, the tilt of the path compared to Earth's orbital plane, can be anything from 0 to a full flip. Interstellar objects we've seen have come in at wild angles, so a high tilt by itself is not a smoking gun. Hypothesis: the particular tilt of 3I ATLAS combined with the timing of where Earth and Mars happen to be, adds up to a long, friendly viewing window from our neighborhood. That's handy for telescopes, and also suspicious if you're in the mood to be suspicious. Speculation. A smart probe plotting a tour would choose exactly that. Angles that keep it lit for our sensors, when that's useful, and hidden when privacy helps. There's also the speed thing. Visitors roll in fast because they're not slave to the sun. Numbers in plain English. A few dozen kilometers per second relative to the sun is normal, call it 20 to 40 kilometers per second, which is around 45,000 to 90,000 miles per hour. That's not warp. It's just the going rate between stars. 31ATLAS lands on the brisk side of that range. Fact. Higher speed reduces the time it spends near the sun, which reduces the total energy it absorbs and changes how ices behave. Hypothesis. A fast pass could delay or suppress the usual comet fuzz, giving us that weird quiet we talked about. Speculation. A fast pass also gives less time for anyone local high. That's us to organize a rendezvous. If you didn't want company, you'd choose haste. Now, about the stops on this tour. Perihelion is the closest to the sun point. Every orbit, even a one-and-done hyperbola, has one. That's the heat lamp moment when buried ices should be most eager to jump into gas. If you're planning camouflage, that's also the noisiest time to be inconveniently on our side of the sun. Fact. Geometry matters more than drama. If perihelion happens while the object is near the sun from our point of view, ground telescopes can't easily watch. They drown in glare. Spacecraft with special shades coronagraph scan, but only if they're pointed and scheduled. Hypothesis. If our mystery guest ramps up activity right when it's half hidden by the sun, we could miss both the how and the how much. Speculation. The same geometry is perfect for any do not disturb work a cautious machine might want to do. Let's demystify gravitational assist, because the route seems to brush past places where that trick is available. A gravity assist is not a slingshot in the cartoon sense. You're not elastically bouncing off a planet. You're borrowing a bit of a planet's orbital momentum by falling into and out of its gravity well at the right angle. Space agencies do it all the time. Voyager used multiple assists to gain speed. Fact. A natural interstellar rock doesn't need free speed, it's already unbound. Hypothesis. Even without a speed boost, flying through a giant planet's magnetic field, the invisible cocoon of charged particles and magnetic lines gives a lab rat's tour of the solar system's weather. If you care about radiation environments or want to sample dust and plasma, a pass near a giant like Jupiter is prime real estate. Speculation. A reconnaissance plan would happily stack a look at a rocky world, a solar heating peak, a safe Earth distance check, and a magnetosphere dive in that order. Now, the honest math of improbable. People toss around odds like 1 in 10,000, but that's only meaningful if you define the game up front. If I pull a card and ask, what are the odds it's exactly the 7 of clubs? The answer is 1 in 52, big deal. If I pull a card and then ask, what are the odds I drew the exact card I just drew? That's cheating. The odds are 1 because I already drew it. Astronomers know this pitfall and try not to backfit the miracle. Fact. There are billions of possible approach angles and billions of possible planetary configurations. Some fraction will look story-ready if you notice them. Hypothesis. We notice the tidy tours because they're tidy, and we ignore the boring fly-throughs that skin the outer system and disappear uninstagrammed. That's selection bias in a nutshell. Speculation. Even after you account for that bias, 31ATLAS's alignment still feels a bit too photogenic, which keeps the ha alive. So how do we test chosen route versus lucky line? By predicting tiny details and seeing if reality plays along. Gravity is the most unromantic partner in the cosmos. It leads and you follow. If you know the shape, speed, and mass distribution of the solar system, you can predict an unpowered object's position to absurd precision days, weeks, months ahead. Fact: small drifts happen when something vents outgassing acts like a weak, lopsided thruster. We call these non-gravitational accelerations, and they often correlate with sunlight and spin. Hypothesis: if 3I-ATLA drifts in ways that track the sun stronger near heat, modulated by rotation, then the route is natural with a side of steam. Speculation: if the path corrects itself at times in directions that do not match heat, spin, or faint jets, then you're watching steering, not sweating. A quick explicable on spin state, because it matters for both the coma and the course. Many comets tumble, not just spin. Tumble means the object isn't rotating cleanly around one axis. It's wobbling like a badly thrown football. That wobble changes which parts face the sun, which changes what vents and when, which can change the tumble again. It's messy but predictable once you measure it. Fact: sunlight itself can slowly change spin-absorbed light, and re-emitted heat act like a tiny torque, the Yorp effect. Hypothesis: if 3I-ATLA says spin drifts in lockstep with what sunlight should do, that's boring in the best way. Speculation: if the spin state stays stubbornly stable through heating events that should kick it, either the mass is distributed in a weirdly stabilizing way, or it's actively stabilized. What about the Earth-check distance that people love to read into? If you're close enough, telescopes feast. If you're too close, pollen in our own atmosphere and the object's speed smear out the data. There's a Goldilocks band tens to hundreds of millions of miles, where we can spectrally sniff faint gases and measure tiny color changes that give away minerals and grain sizes. Fact: a lot of natural flybys pass through that good enough band just because there's a lot of space in it. Hypothesis: if 3I-ATLAS lingers in that sweet spot longer than a straight hyperbola, predicts slower fading, longer on-stage time, that's a red flag. Speculation: an artificial bus might break just enough by venting or other means to stretch the observation window while claiming coincidence. Then there's the final act some folks can't stop circling, the pass near a gas giant's magnetosphere. Jupiter, Saturn, Uranus, Neptune, take your pick each, wraps itself in a huge, invisible storm of charged particles and twisting fields. They're not gentle. Fact: spacecraft brave them because the science payoff is huge. Instruments taste plasma, sniff dust, listen to radio hiss. Hypothesis: any probe built to last in the interstellar medium, which is full of cosmic rays and random grit, can handle a quick magnetosphere dip. Speculation: the dip could also be functional, like putting a finger on the wind before heading back to deep space, or a way to scoop electrically charged dust that's stuck to the object along its path samples from us, carried away by them. Let's ground this with an image. Picture a curling stone sliding down the ice. If it's untouched, you can chalk the curve up to friction and spin and be right. If, every so often, a broom nudges the ice in front of it just so, the path still looks pretty, but the tiny timing mismatches give the trick away. Our job with 3I Atlas is to watch for the broom, accelerations that don't marry heat, geometry that flatters secrecy, encounters that happen to land in the best-in-class windows for science again and again. None of this proves intention. Nature has a way of beating us at chess by accident. But intention, if it's there, is hard to hide at scale. You can fake a spectrum in a pinch. You can't fake weeks of tiny course changes that all coincidentally keep the object in camera-friendly lighting, or radio quiet exactly when receivers are pointed, or an outburst that happens only when our best eyes are blinded by the sun. The more we track, the more those coincidences pile up or fall apart. So yes, the route is clean. Yes, the beats are tidy. Could that be luck? Absolutely. Could it be design? If it is, the design will slip somewhere, because physics makes every lie expensive. That's why we keep watching. Because if a rock is just a rock, gravity writes the script. And if it's not, the script has edits. You catch them in the margins. All right, let's zero in on the part that keeps making astronomers stare at their screens like the Wi-Fi just froze. The quiet. A big dark interstellar visitor rolling sunward ought to start cooking a little as it warms up. When ices near the surface get sunshine, they sublimate solids straight to gas, and you get that fuzzy halo called a coma, sometimes a tail, and a mix of gases that light up at very specific colors when sunlight hits them. Think of a neon sign for molecules. Two of the early birds we look for are CN and C. Cyanogen and diatomic carbon love to shout in the visible spectrum once they're free. With a 7-mile-ish chunk, you'd expect at least a whisper as it crosses a few astronomical units. With 3 IATLAS, the whisper has been more like a shrug. Here's the split so we don't get lost. Fact: comets usually start muttering around 5 to 3 AU. The exact distance depends on what's near the surface and how crumbly or crusted over it is. Fact: we've caught water ice and organic hints in 3 I-Atlas's infrared signature nothing alien there. Just the usual space pantry. Fact: telescopes with the right spectrographs can sniff parts per billion levels of some gases if the geometry is kind. Hypothesis: if the surface has a thick, sun-baked crust, an insulating blanket built by radiation and micro-impacts over eons, the first round of heating might only puff through pinholes, so you get gas, but it hugs the surface and stays faint. Hypothesis number 2: if the spin is awkward a wobble, not a clean pirouette sunlight, might keep revisiting the same cold spots, delaying the real venting. Speculation: if someone wanted to keep this thing from looking like a classic comet until it was inconvenient to watch, a thin, refractory varnish on the outside would do the job. It's not sci-fi. We spray clear coats on spacecraft to survive exactly this kind of radiation and heat. Before we jump to spycraft, it's worth understanding how hard it is to shout "no gas detected" without crossing your fingers. You don't look once and declare victory. You stack nights of data. You dodge moonlight. You watch the object's angle to the sun, and you keep an eye on the telltale colors where CN and C usually sing. If the scene is messy, or the object is too close to the sun on the sky, you get glare. If dust from the object is present but sparse, it can actually hide the faintest gas lines by scattering light in the same band. Non-detection with a healthy error bar means below our threshold. So far, that's not nothing. It narrows the possibilities. A comet scientist I chatted with put it this way: absence is a clue, not a conclusion. Meanwhile, the radar gun part of the story keeps running in the background. Trajectory is the grown-up chaperone here. Gravity tells us where an unpowered traveler goes and when. The tiny ways 3 IATLA fails or succeeds to match that prediction is where the truth leaks out. If a vent opens on the day side, you get a gentlest of gentle push. The acceleration is small millimeters per second per day small, but it's there, and it tends to correlate with sunlight and rotation. That's the sweating comet signature. If the little pushes arrive when the surface shouldn't be venting, or from directions that don't make thermal sense, that's the "hey, who's steering" signature. We measure that by fitting the path and checking the residuals, how far reality strays from the curve. Less romance, more spreadsheets, but it's how you catch a broom nudging the ice in front of the curling stone. Surface texture gives away a lot too, and you don't need a glamour photo to read it. As the angle between sun, object, and us changes, the brightness changes, what astronomers call the phase curve. Powdery, fluffy regolith scatters light differently than lumpy rock or smooth ice. Every so often, something mirror-like produces a glint, a sudden spike. Meteors do it, satellites do it, even some asteroids flash. If 3i Atlas gives a tight, Specular wing that repeats with its rotation, that's interesting. It suggests facets or plates rather than the charcoal matte surfaces we expect on long exposed ice and dust. Fact: most comets are blacker than barbecue briquettes, reflecting only a few percent of sunlight. They don't usually wink, they smolder. Hypothesis: a hard crust speckled with brighter patches could fake a glint without any panels. Speculation: an engineered skin with layered, refractive stuff, think anti-glare for the cosmos, could keep the albedo low but still throw a controlled sparkle in just the right conditions. Then there's the chemistry classroom, which is where the real fingerprints hide. We're not only counting which molecules show up, we're weighing their isotopes. Water with extra heavy hydrogen deuterium carries the story of where it condensed. Carbon and nitrogen isotopes sketch the kitchen where the organics were cooked. If 3I ETLAs keeps its gases to itself until it's half hidden by the sun, we still have a shot at catching the after party. Infrared telescopes can read hot dust as it cools, and you can sometimes back out what burned off by the grains left behind. One thermal modeler gave me a line I loved: "Dust is destiny." If the tail dust, when it finally appears, is dominated by fluffy, fragile grains, that argues for a pristine, natural crust cracking open on schedule. If it's glassy, compact, and oddly uniform, that's weird. Nature usually serves trail mix, not uniform pellets. Radio check? Someone always asks. The honest answer is that we listen, but quietly, and we don't expect a hello. Narrowband carriers, odd chirps, artificial-looking repetition radio telescopes can and do scan for that, especially near close approaches. But a smart machine built to blend in wouldn't broadcast from center stage. It might use tight beams aimed nowhere near Earth, or optical communication we can't see against the sun's glare, or no active comms at all, just record and leave. So radio silence is not proof of anything except restraint. What is testable, even for a cautious probe, is leakage. Electronics, even shielded, bleed a little at harmonics. Switching power supplies tick. If the spectrum stays boring across many bands, while we're close and pointed and sensitive, that's a point for natural, or at least very careful. Timing is the other tell. A natural object outgasses when and where heat says so. A disguised machine would hide activity during our best windows and do its noisy business when our best eyes are blinded by the sun. That makes perihelion geometry an honesty test. If 3IATLAs erupts with textbook chemistry exactly while it is too close to the sun's glare for ground telescopes, only to go quiet again when it glides into easy view, you raise an eyebrow. It could be coincidence. Nature doesn't schedule around our calendars. But it's the kind of coincidence that's cheap to avoid if you're not trying, and expensive to maintain if you are. One mission planner put it dryly: physics doesn't care about your PR, but operators do. To keep this from drifting into campfire spookiness, let's pin numbers to the squishiest parts. Non-gravitational accelerations in comets often live around 10y to 10y meter per second squared near peak heating. Spin periods are hours, not minutes. Changes in spin rate across a perihelion season are usually percent level at most, unless the thing is shedding mass. Gas production rates scale with sunlight like a dimmer, not an on-off switch. Translated to human terms, if we see 3IATLAs pick up a tiny, steady push that mirrors sunlight, and then a gentle taper, that's a sweaty rock doing sweaty rock things. If we see flatline calm through a heat bath, followed by a sharp, short burn that happens to peak when we can't watch, then a sudden return to calm, that's a narrative, and narratives ask to be explained. And because the internet loves a reveal, here's the boring but bracing reality from people who live in the data. Give us time. Coding faint spectra into a usable signal takes nights. Mapping a phase curve needs weeks of angles. Fitting for sneaky accelerations means letting the object move far enough for the math to separate heat puffs from measurement noise. This is not stonewalling. It's how you avoid fooling yourself. The universe is generous with surprises, but it's savage to rushed conclusions. So where does that leave the pub table crew? Somewhere between patient and nosy. You keep your ears open for emissions that finally show. You watch the light curve for a glint that repeats. You check the trajectory fit for those telltale residuals. And you circle perihelion on the calendar, because that's where honesty has the least room to hide. If 3IATLAS is just a big, ancient snowball from another sun, it will eventually act like one under a heat lamp. If it's playing dress up, the seams will show under the stress. One last thought from a dynamicist who has watched more rocks than most of us have hot dinners. Nature loves to look intentional when it's not. That's why we test the hunches. Perfect. We're not chasing little green men. We're chasing the difference between sweating and steering, between varnish and crust, between a silent winter road and a quiet electric motor. The instruments are ready. The geometry will roll through its paces, and luck nature's favorite co-conspirator will either make this look like the neatest tour in years, or quietly erase the tension and leave us with a beautiful, boring comet that taught us, once again, to check before we leap. If you ask most astronomers what 3IATLAS really is, you'll get an answer that sounds like a sigh in lab coat form. A big, old, crusty comet from somebody else's backyard. Not because they're allergic to wonder, but because the job is to start with the explanation that needs the fewest miracles and add weirdness only when the data forces it. That little rule of thumb has a fancy name, Occam's razor, and it has saved science from a lot of expensive goose chases. When the first pulsars were found, the signal was so clockwork that someone jokingly labeled them LG little green men. Turned out to be dead stars with magnetic tempers, not a neighborhood group chat. Same reflex here. Begin boring and let the universe argue you out of it. On the boring but true side of the ledger, nothing we've seen so far breaks physics. A low albedo surface, think 4% reflectivity, blacker than a charcoal briquette, matches a lot of comet nuclei. A rotation period of hours, not minutes, is normal for something this big. Non-detections of early neon sign gases could be explained by a hard radiation crust, by a spin that keeps the same cold patches pointed at the sun, or by an inventory of volatiles that just need more heat. One comet specialist put it with the kind of deadpan that only comes from too much coffee. If it looks like a snowball and sulks like a snowball, give it sunshine. The natural script says, wait for 2 astronomical units, then 1.5 astronomical units. See if the stove finally turns up and the kitchen smells like CN, C, HA, O, and friends. There's also the awkward truth about how our attention gets captured. We don't write breathless threads about interstellar visitors that skim the outer system and fade elegant and unremarked. We shout about the ones that thread a few needles and slip past familiar cameras. That's selection bias with a side of human nature. If 1 million coins are being flipped in the dark, somebody somewhere is getting 10 heads in a row. The people texting the group chat are the ones who noticed. A dynamicist I like to bug about this stuff calls it apophenia season, the time when pattern-hungry primates go truffle hunting in noise. It doesn't mean there's nothing real. It means the bar for calling it real is higher. Mainstream caution isn't a vibe. It's a method. Data gets shared early in preprints, then it gets needed and re-needed through peer review. Then independent teams try to break the conclusion with their own pipelines. A non-gravitational acceleration? Great, fit it with a sunlight correlated term, and then make sure the same signal appears when a different group, with different software, different assumptions about the scattering of dust, and different weighting of outlier measurements, takes a crack, a glint in the light curve. Wonderful, does it repeat with the same phase after 2, 3, 4 rotations when the viewing geometry changes by a few degrees? A whiff of an odd molecule? Okay, does it show up in another instrument, another wavelength? Or was that night just humid and mean? The quote you hear a lot behind closed doors is not romantic. Extraordinary claims are fun. Extraordinary evidence is work. All of that can sound like a buzzkill from our pub table, but it's how you avoid being seduced by coincidences. The trajectory, for example, is the current Rorschach test. The "this looks designed" crowd points to a chain of close but safe flybys that feel like a guided tour. Mars for dawn-side imaging. A perihelion tucked behind the sun, where you can be loud when we can't listen. A tidy Earth distance pass for our best telescopes. A swan through Jupiter's magnetosphere, like it's a lab bench. The caution crew counters with the math. In a universe that tosses countless rocks in countless directions, some paths will line up suspiciously well with our calendars and vantage points. Low probability is not the same as impossibility. It's just the tail of a big distribution wagging near our eyeballs. So what would it take to shake the consensus off its comfy sofa? Not vibes. Patterns that refuse to die when you change the lighting. If 3I ATLAS shows a persistent, sunlight-independent push-tiny, but clean, something like 10 meter per second squared, that doesn't care whether the day side or night side is facing the sun, that's hard for a sweating comet to explain. If the light curve keeps throwing razor-narrow specular flashes that repeat like a metronome, even as the phase angle changes, that smells like flat facets, not lumpy regolith. If the chemistry finally sings, but the tune is too tidy uniform grains, oddly narrow temperature spreads, isotopic ratios that look hand-picked rather than born messy in a cold disk, that's curious. And if a radar ping or a polarimetry run hints at geometry that nature usually avoids planes and edges rather than rough blobs, you'd see even the grumpiest skeptics sit up. But here's the split we promised to keep honest. Facts first. So far we have a big, dark object on a hyperbolic track with infrared hints of water ice and organics. A rotation that doesn't demand heroics and early-stage shyness about venting. Hypotheses. A tough surface rind, interstellar weathering that cooked the skin into a poor heat conductor, or a thermal inertia profile that simply delays the show. Speculation. A skin you'd call a varnish. Refractories layered to suppress classic comet signs until the geometry favors secrecy. A communication system that only wakes up when the sun is between us and the target, using beams we're blind to at those angles. A sampling suite built to hoover dust in retrograde and power nap all the way out. With speculation, you don't ask, could it be done? Answer, sure, by someone much smarter. You ask, does the data beg for this story? Or are we dressing coincidence in a tux? Even the frustration has a schedule. Perihelion is the honesty booth. If the coma blooms on cue when heat is maximal and we're handicapped by glare, then fades as geometry improves. We note the convenience and ask for a replay in December and March when the viewing gets good again. If the outbound leg finally gives us the whole molecular chorus, isotopes and all, we check whether the fingerprint lines up with a natural kitchen-heavy hydrogen, a little high or low, carbon and nitrogen telling us, I was born around a metal-rich star, or I'm a child of a colder nursery. If the outbound leg stays suspiciously tidy, no dusty mess, no ragged tails, no spin changes from uneven jets, that's when the conference coffee gets more tense. Meanwhile, the radio question deserves the least drama. We're listening across sensible bands. We set narrowband traps. We watch for repeating oddities that don't match solar or planetary noise. And yes, nothing screams made thing like an unambiguous carrier with a Doppler drift in just the right way. But if you were building a watcher to blend in, you'd rather record than broadcast. You'd rather point your beam away from the only species in the room that names things, or use optical links that drown in the sun's glare, or trickle power so gently that your electronics don't shed harmonics above the thermal floor. Silence here is not a verdict. It's what you'd expect from both a sleeping snowball and a careful machine. There's one more reason the mainstream leans natural, and it's not cynicism, it's accounting. Every time science has broken the "it must be artificial" glass, it's been because nature surprised us with a new trick. Quasars looked like alien lighthouses until black holes and accretion disks put on a physics show. Fast radio bursts auditioned for beacon duty until galaxies full of magnetars raised their hands. The safe bet is not that intelligence is absent. It's that the universe has more ways to be weird than we have ways to imagine intent. A planetary scientist I pester too often sums it up with a shrug. We prefer boring and true to exciting and wrong. Exciting and true is allowed after the paperwork. So we keep the two-track brain switched on. On one track, bake the data into something testable, let the calendars roll, and watch the numbers tell you whether heat or steering is in charge. On the other, keep the door cracked for the possibility that somebody else is very good at hiding. If 3I-ATLAS is just a proud, ancient snowball, the show will get messy in predictable ways, and the lab notebooks will be happy. If it's more than that, the mess will be too neat, the pushes a shade too clever, the silence a touch too well-timed. Either way, the fun part is the same. We'll know because the universe left fingerprints, and we learned where to dust. Before we can judge whether 3I-ATLAS is acting strange, it helps to remember what normal but interstellar looks like. We've actually hosted 2 out-of-town guests already, and they could not have been more different. The first, Oumuamua, blew through in 2017 like a rumor with a return ticket. It was small somewhere in the few hundred-meter club, and already on its way out when we noticed. No fuzzy coma, no tail, no dust. Then came the kicker, a tiny push away from the sun that didn't line up with the usual steam vents make thrust story. That acceleration was small, think millionths of a meter per second squared, but stubborn. Some people squinted and saw a thin pancake, others a long cigar, and a few said the quiet part out loud. What if it's a sail? Most astronomers didn't buy the sail, not because it's impossible, but because nature is great at inventing materials and shapes we hadn't put in the catalog yet. As one observer shrugged to me later, Oumuamua broke our expectations, not physics. 2 years after that, 2I Borisov arrived and immediately calmed everyone down. It did all the comet things by the book. It started venting far out, built a bright coma that fuzzy atmosphere comets wear when they cook, and wagged a tail like a golden retriever. Spectra the color fingerprints that tell you what's in the gas lit up with water, carbon monoxide, and other usual suspects. We even saw chemical ratios that marked it as not from around here. Perfect. Textbook interstellar snowball. A researcher I met at a conference summed up the mood. Borisov smelled like comet, looked like comet, tasted like comet. Please don't quote me on the tasting part. Now slide those 2 case files next to 3I-ATLA. The headline difference is size. We're talking roughly 7 miles across, call it 11 kilometers, with the usual uncertainty bars you get when you're judging something dim and far. That's not a pebble. That's a county. The surface is dark around 4% reflectivity, which is freshly used charcoal territory, and the spin period lands in the hours not minutes zone, which is comfortable for big bodies that don't want to rip themselves apart. Infrared hints of water ice and organics? Check. Early coma drama? Not really. The classic comet perfume, those bright lines from cyanogen and diatomic, carbon that pop out as soon as the stove warms, has been shy so far. That's either a timing story, needs more sun. A crust story, the toffee shell, is insulating the good stuff. Or our first hint that its chemistry is its own kind of weird. Trajectories are where our brains start seeing faces in clouds. Oumuamua took a pretty dull path by comparison. Sweep in, swing past the sun, bye. Borisov did an inner system scoop and left us plenty of time to gawk. 3I-ATLAs is the one that makes the eyebrow twitch. inbound on a retrograde lane, meaning it swims upstream against the planet's threading opportunities near Mars, then hiding perihelion, the closest to Sun moment, behind the glare from our point of view, then sliding past at a respectful but handy distance for our biggest eyes, and finally cutting through Jupiter's magnetic bubble like a tourist who scheduled both the museum and the factory tour. Facts are facts. That sequence is improbable, not impossible. Whether that's clever or coincidence depends on how allergic you are to long odds. The comparison game helps because it tells us what to watch for next. With Oumuamua, the argument lived and died on whether the push matched sunlight, a sail, or a fluffy surface, or secret outgassing. With Borisov, the story was all about chemistry and dust. It vented early and often, and the ratios pointed to a place colder than our backyard. With 3IATLAS, we have time and mass on our side. A big object is a thermal cruise ship. It heats slowly, vents unevenly, and its spin can change if jets start acting like tiny thrusters. If this thing is natural, we should see that Messines's bloom as solar energy ramps up, a coma that grows and changes texture, a tail that responds to sunlight and solar wind, a rotation that drifts by seconds or minutes as jets kick. If it's not just natural, the pattern might be too tidy stable spin in spite of heating, outgassing that behaves like it's on a dimmer switch rather than on a hot plate, or specular glints in the light curve that repeat like a metronome, even when the viewing angle changes. Let's talk tests without the lab coat. Photometry, watching how bright it gets and how that brightness wobbles as it spins, is our stethoscope. A lumpy snowball gives you a soft heartbeat. A flat facet gives you clicks. Spectroscopy, splitting the light to see chemistry, tells us who's in the gas and in what ratios. A natural kitchen is messy. Broad temperatures, mixed grains, isotopes that tell a story of a particular star's nursery. An engineered pantry, if anyone were that bold, might look weirdly clean or suspiciously tuned. Polarimetry, measuring how light is polarized when it bounces, can hint at texture. Rough, fluffy dust polarizes differently than smooth plates. Radar, if we can get a ping on a target that dim, gives you shape and surface feel. Nature likes potato shapes with rounded edges, not rulers and 90-degree corners. And finally, astrometry. They're precise. Where is it exactly? Work lets us spot tiny pushes. If you see a non-gravitational nudge that doesn't care about sunlight, that's a raised hand. Because we promised to keep the lanes clear, let's separate the deck. Facts. 3I Atlas is big, dark, cold so far. Inbound fast, tens of kilometers per second relative to the sun, on a hyperbolic path that says passing through, with chemistry that whispers water and organics in the infrared, but hasn't belted out the loud comment songs yet. Hypotheses. An interstellar tan, radiation-baked rind, plus low thermal conductivity delaying venting. A spin state that keeps cold real estate facing the sun long enough to postpone the show. Or a volatile inventory skewed toward species that don't light up the same way our telescopes are trained to expect. Speculation. A skin deliberately layered to vent when geometry hides it. A sampling strategy that loves retrograde because it rams through more dust. A communication scheme that wakes only when the sun sits between it and our antennas, so our sensors are literally blinded by daylight. An engineer I know calls that being polite. You don't text when you know someone's driving. How do Oumuamua and Borisov help us navigate between the lanes? They're our calibration points. Oumuamua taught us that absence of a coma doesn't mean rock. It might mean weird ice, weird structure, or just bad luck with timing. Borisov reminded us that interstellar can still look like the comets in our own freezer aisle. 31ATLAS is the stress test. Can a giant, pristine interstellar nucleus really hold its breath this long? A comet physicist I pester too often put it this way: big snowballs don't do subtle forever. Heat is patient. If the outbound leg after perihelion, when the oven's done, still looks tidy, then even the conservative voices will start tapping their pens. This is also where selection bias sneaks into the room and steals our snacks. We remember the dramatic guests. Oumuamua was all questions and no tail. Borisov was the poster child for C models work. 3-1 ATLAS walks in carrying a timeline that just happens to fit what our biggest telescopes can do this year. We did not pick the object because of that. We just pay attention when the universe picks one that's convenient. A statistician I once cornered at a poster session sighed and said, "Every improbable thing is improbable until it happens. Then it becomes a story." The only cure for that kind of narrative gravity is prediction. If we can say what a natural 3-eye atlas should do across the next 6 months, and what an artificial 3-eye atlas would probably not be able to hide, then we can grade reality against the syllabus. There's one last lesson from the earlier visitors that's easy to miss. Humility buys you discoveries. With Oumuamua, the loudest arguments sometimes outran the data. We ended up with a lot of heat and not as much light. With Borisov, the field quietly stacked spectra until the picture was boring and correct. With 3-eye ATLAS, we get the luxury of preparation. We can coordinate instruments across wavelengths, line up radar windows, tune photometry campaigns to catch spin state changes, and plan for geometry traps at perihelion when our view is worst. A mission designer I spoke to about this season joked, "It's not first contact or bust. It's first principles or bust." So, is 3-eye Atlas hiding something big? Today's honest answer is the one that keeps the lights on in the observatory. It's hiding its hand until the sun forces it to play. If that hand is just pristine ice and carbon-rich dust from a star older or richer than ours, we'll still learn more about how planetary systems bake their comets than we've ever known. If the hand turns out to include something laid out, overstable, suspiciously polite, or a little too clever about when and how advanced, then the conversation gets louder, and appropriately so. Either way, the comparison with our previous guests keeps us from flying off the handle. We've seen quiet, and we've seen noisy. Now we get to see what a giant does when the heat is on. If you hang around astronomers long enough, you learn that nothing starts an argument faster than the word improbable. With 3-eye ATLAS, the fight isn't over telescopes or budgets. It's over whether this thing's tidy tour is a wink from the universe, or just the cosmic equivalent of flipping 5 heads in a row. The path is undeniably neat. Retrograde lane, a courteous swing by Mars in early October, perihelion tucked behind the sun on October 29th, a not-too-close December hello to Earth at about 170 million miles, 270 million kilometers. Then straight through Jupiter's magnetic backyard in March. If you're building a story, that sequence practically writes itself. If you're building a case, it's where you have to slow down. A dynamicist I pestered about this calm voice, wild hair, the whole package gave me the kind of quote you cross-stitch on a lab coat. Rare isn't suspicious, persistent is. In other words, one weird coincidence is a headline. A chain of precise choices that repeat across different objects becomes a pattern. We don't have a chain. We have one big visitor doing a lot of cinematic blocking. The way to keep our balance is to remember how our brains cheat. There's apophenia, the impulse to see a face in toast, and selection bias, the habit of only remembering the toast that looks like a face. Interstellar rocks that never come near our line of sight don't get names. The rare ones that parade past our best instruments get late-night talk shows. That doesn't mean we shrug off the math. People have run the simulations and coughed up odds that sound like raffle tickets you wouldn't buy. 1-in-10-1000-ish for a path is convenient, depending on how tight you draw the bullseye after you see the dart. But statistics are slippery in post-game mode. If you decide after the fact that the trick was Mars within 30 million kilometers at dawn, Perihelion when Earth is blinded, Jupiter within 50 million kilometers. Of course, the odds look microscopic. If you'd written down Venus at dusk, Earth occultation in May, Saturn crosswind, and then celebrated when those happened instead, the same math could make a different path look faded. A statistician friend of mine has a less poetic version of Occam's razor for this. Pre-register your surprise. So let's try. If 3i Atlas is a natural object, warmed by sunlight and bullied by gravity, we expect certain things that don't care about our conspiracy boards. Solar heating rises as it drops from about 3 astronomical units to 2 to 1.36 astronomical units at perihelion. Ices go from polite to rowdy. A coma should wake up measurably water vapor, carbon-bearing gases, by the time it's inside roughly 2 astronomical units, with wiggle room for crust and composition. The rotation period, which we've pegged in the ballpark of half a day with some uncertainty, should drift by tiny but trackable amounts if gas jets act like wristwatch-sized thrusters. After perihelion, as it cools on the outbound leg, activity should fade, not hold steady like a space heater on a timer. The light curve, the way brightness rises and falls as it spins, should evolve, as new vents open and dust lofts into a loose cloud. These are boring predictions, and that's the point. Nature is gloriously messy. If it's not just nature, messines gets hard to fake. You can engineer a surface, but you can't make the sun forget where you are. If outgassing appears in carefully gated windows, maximum when our line of sight is worst and minimum when every eye is on it. If the spin period sits on a stubborn plateau, regardless of heating, if the chemistry that finally shows up looks too clean, say, narrow band emissions that don't broaden with temperature or isotopic ratios that look printed rather than brewed in a star's nursery. That's when even the cautious people start setting down their coffee. A senior comet person put it more gently than I ever could. The universe is generous with noise. When you hear a metronome in a thunderstorm, you pay attention. Now about that Jupiter pass, because this is where the script flips from spy novel to lab practical. Jupiter's magnetosphere, the bubble, carved by its magnetic field, stretches tens of millions of miles, full of charged particles whipping around at speeds that would give a toaster an existential crisis. Anything passing approximately 33 million miles, about 53 million kilometers, over the cloud tops in mid-March will feel that environment. We have Juno there, a grizzled veteran with instruments that can sniff changes in the magnetic field and the dusty plasma soup. If 3i Atlas is shedding material, Juno might taste a few crumbs indirectly, the way you taste salt in sea air without seeing the ocean. If it's carrying anything that interacts with magnetic fields in an uncomet-like way, we might see faint ripples where none should be. Between now and then, we still get our best classic tools. Photometry, the heartbeat monitor, should catch any sudden changes in spin or shape cues. Spectroscopy, the chemistry whisperer, should start pulling out the usual comet songs. Water at infrared bands, CN and C2, and the optical, once solar UV, it's the party started. Radar, if the geometry and power budgets line up, could ping the surface and map roughness. Natural boulders and pits scatter radar like gravel. Engineered smoothness does not. None of these alone proves a thing. Together, they color in a picture that either looks like a familiar family portrait or a forgery with good lighting. The SETI people, the Are We Alone crowd, are watching all this with a mix of curiosity and caution. Their discipline has scars from false alarms and wishful thinking, and they've built protocols the way climbers build anchors, redundant and boring by design. One of them told me, mid-coffee refill, we don't declare signal unless it survives being bullied. For an object, bullied means independent teams with different instruments converge on the same weirdness, and the weirdness persists when vantage points change. A spike that only appears when Earth is blind is not evidence. It's an alibi. There's also the practical puzzle of what proof looks like when the other side If there is another side, could be playing on a field we barely understand. We're used to smoking guns and narrowband radio ping, a right angle in a radar echo, a thermal pattern that screams machined. But sufficiently advanced camouflage muddies those. So the bar becomes cumulative. Do the non-gravitational accelerations line up with solar pressure in a way that demands paper-thin, reflective structures, yet the reflectivity we measure stays stubbornly low, around 4%? Do we see surface glints that repeat with geometry, not with rotation, like a panel catching the sun? Do isotopes whisper a star older and metal richer than ours, while the venting behaves like a thermostat? You don't need a single smoking gun if you can stack a dozen whirlwinds that all point the same way. And yes, there's the human part. We're not neutral observers. We want a story. Rock behaves like rock is a story with a nap ending. Visitor behaves like scout is the binge watch. That's exactly why the community has tried to box itself in with predictions and timestamps. If you say in September, we expect a coma by 2:00 and in October, and in October it's stubbornly clean, you don't move the goalposts. You say, that's odd, and you update the model. If in December the spectra finally light up, but only in bands we couldn't see earlier, you don't retrofit intention. You check your sensitivity curves. A mentor of mine once said, good science is just good memory with humility. So where does that leave the barstool verdict tonight? Somewhere between calm down and keep watching. Facts first. A big, dark, cold object on a hyperbolic pass, inbound at tens of kilometers per second, with infrared hints of water and organics, but no loud gas lines yet, and a route that happens to serve our instruments, a tasting menu. Hypotheses next. Crust delaying venting, spin orientation tricks, chemistry from a star with a different heavy element recipe than ours. Speculation last. A deliberately layered skin, retrograde chosen to sample more interplanetary dust per second, perihelion time to operate while we're blinded, and a magnetosphere pass aimed at either data collection or stress testing. None of those ideas pays rent until the sun heats the apartment. If you want a small, sane homework assignment while we wait, it's this. Remember the dates. Early October for Mars, late October for perihelion, mid-December for the Earth-side deep look, mid-March for Jupiter's gauntlet. At each checkpoint, ask the same boring questions. Did the coma arrive when it should? Did the spin budge the way physics predicts? Did the chemistry look like a kitchen or a clean room? The answers won't settle the alone, not alone question forever. They will decide whether 3I Atlas joins, Borisov in the Nature is Awesome folder, or Aumua in the Nature is Weird folder, or whether it forces us to open a drawer we haven't labeled yet. Okay, let's talk about the plan, the practical, boots on the ground version of what do we actually do with a maybe weird rock that's dropping by for the holidays. Because it's one thing to sip a beer and trade theories, and it's another to turn those theories into pointing schedules, instrument modes, and hard calls about what to try and what to leave alone. Think of 3I Atlas as a shy animal at the edge of a clearing. We want a good look, maybe a hair or two from the fence it brushes, but we don't want to spook it or fool ourselves by stomping in and declaring we've seen Bigfoot because a twig snapped. The conservative playbook starts simple. We watch a lot with many eyes. Not just the celebrity telescopes with their glossy mirrors, but the workhorses that grind through night after night. Photometry to keep a heartbeat on brightness and spin. Spectroscopy to sniff the chemistry as the sun turns up the heat. Radar if geometry and power cooperate to ping the surface and see how rough or smooth that skin really is. None of these tools is flashy on its own. Together, they act like different senses: sight, smell, touch, cross-checking the story the object tells without saying a word. A comet with a crust will complain in a certain register. A crust with a secret will try to keep the song the same even as the temperature changes. Nature hates consistency when things are heating and cooling. a comet veteran told me with a grin. If it stays too tidy, your eyebrows earn their keep. There's also the etiquette question, which sounds silly until it isn't. Do we poke it? Radar is a poke. Active illumination is a poke. A high-power beam says, "Hey, we're here, hold still." If you're a planetary defense person who spends their life worrying about rocks with bad manners, you want the data. If you're a SETI person who has read one too many novels about waking dragons, you vote for patience. A mission planner put it in less dramatic terms. First, do no harm to your own inference. If your test risks changing the subject of your test, think twice. That's doctor speak for don't whack the beehive to confirm it's a beehive. Even if we keep our hands politely to ourselves, there's still a ton we can do. The December window when 3I ATLAS is about 170 million miles out is made for infrared work that can pull out faint fingerprints of water and carbon-bearing gases, even if the coma is shy. If those lines broaden and strengthen with heating like they should, chalk one up for rock with issues. If they flick on and off, like a motion-activated porch light, that's interesting. The light curve, the little rise and fall as the body spins, ought to drift as jets act like tiny thrusters. A dead stable spin under changing sunlight is either a strange bit of luck or a sign there's more going on than sunshine and ice. We don't need fireworks, a spectroscopist told me. We need stubborn facts. The sky is generous with those. Then comes March and Jupiter's neighborhood, which is the closest thing we'll get to a stress test. That magnetosphere is not friendly to delicate electronics, nor is it gentle on dust. If 3I Atlas behaves like a big natural snowball, the interaction should look like 1,000 other plasma encounters we've seen, scaled up. If something about it couples to the field in a way comets don't say, a crisp little signature where we expect a smeared-out Mesjuno's instruments might notice. Not a smoking gun, but maybe the outline of a holster. Parallel to the watching and waiting is the question everyone keeps sneaking up on and then backing away from. Do we try to go there? Intercept missions aren't like ordering a rideshare. You don't whip up a probe between now and March and beat an object moving tens of kilometers per second to a precise meeting spot. But there are middle options. Piggyback mode on existing spacecraft. Opportunistic observations from Mars orbiters during the October pass. Coordinated campaigns with small-sat telescopes that can stare longer than the big guys who have to split their time. None of this is as satisfying as a flag-planting flyby, but it's how you turn curiosity into signal. Many modest data points that agree for boring reasons. There's also an ethics layer that isn't CFE, it's just good fieldwork. If you're a biologist and you find a new species, you don't pour bleach in the stream to see what happens. You watch first. You compare. You replicate. That's what the community is doing here, sometimes painfully slowly. I'd rather miss a weird trick than break the very thing that would have shown me, a mission designer said. That restraint isn't romantic. It's practical. If 3I Atlas is natural, patience rewards us with clean baselines for the next visitor. If it's not, patience keeps us from creating artifacts we later mistake for clues. Now, since we promised to label the shelves, facts, hypotheses, speculation. Facts. It's biggish, dark by space standards, and coming in hot on a hyperbolic path. Infrared hints at water and organics. The isotopes don't match our backyard. And so far, the classic comet gases are playing hard to get. Hypotheses. A crust seasoned by interstellar radiation could be hiding more reactive ices. A spin axis pointed just so could delay visible venting. And a metal-rich birth star could leave a chemistry that slides our expectations off-key. Speculation. A layered skin with engineered pores that open when we can't see. A retrograde lane chosen to plow through more dust per second. A Jupiter dive not for drama, but for data about our biggest magnet. All three drawers stay open. None gets to slam shut until the sun does its interrogation under bright lights. what would count as the kind of nudge that moves the needle, not a miracle. Something dull and durable, a non-gravitational acceleration that refuses to track any gas we see. A thermal response that stays flat across a heating curve that should make it squirm. A surface radar echo that says polished where rubble should be. Or, more likely, a handful of small anomalies that all point the same way, the way a dozen tiny clues can beat a single flashy witness in a good detective story. If you need one silver bullet, you're in trouble, one of the cautious folks told me. I'd take 5 lead ones that all hit the same target. Of course, there's the meta question. What if we do everything right, and it still won't confess? Then we get the gift we didn't ask for, but probably need the habit of being ready next time. 10 years ago, Oumuamua showed up late and left early. We weren't ready. Borisov was kinder and taught us that interstellar can look delightfully normal. 31ATLAS is giving us homework with a generous deadline. We are building muscle. Better survey cadence, faster follow-up, clearer pre-registered predictions, and a willingness to say, that's odd, without immediately translating it to that's alien. And if, in the middle of all that, somebody hears a narrowband whisper from the same patch of sky, or a little glint repeats with a geometry that screams, panel, then the conversation changes, not because our hopes got loud, but because the evidence did. Until then, the barstool rule holds. Tell me what you expect before the show starts, then tell me what actually happened when the curtain falls. Everything else is mood lighting. So our job in this chapter of the story isn't to crown a king. It's to set the stage so that the next act perihelion, the Earth-side deep look, Jupiter's gauntlet, can deliver an answer we deserve, not one we begged for. Whether 3I Atlas leaves us a polite note that says, just passing through, or a riddle we'll chew on for years, we'll have done the one thing that always pays off. We watched carefully. We wrote things down, and we let the sky be strange without forcing it to be magical. Here's the part where we stop juggling theories and actually stack them on the table to see which ones wobble. We've been circling 3I Atlas like it's the quiet person at the party who might have the best story. Now we pull the threads together and ask what the evidence really buys us, not the headline, not the campfire tale, just the most honest picture a bunch of photons can paint. Fact first, because that's home base. We've got a big visitor, roughly 7 miles across, give or take a mile. Call it approximately 11 kilometers plus or minus 1 to 2 kilometers. Dark as old asphalt with an albedo near 0.04, rotating in about 12.4 hours, give or take a few minutes, depending on which light curve you trust. It's inbound on a hyperbolic path at roughly 33 kilometers per second, relative to the sun, which is plenty fast, but not absurd, and the tilt of its path sets it up for a series of conveniently observable moments. Early October near Mars, around 18 million miles. Late October swinging by the sun at 1.36 astronomical units. Mid-December at about 170 million miles from Earth. Then mid-March skimming through Jupiter's magnetosphere, around 33 million miles above the clouds. The spectra point to water ice and carbon-bearing stuff. But some isotopes don't match our neighborhood's usual recipe, and the usual early comet smoke signals, those bright, friendly molecules that shout, "Yep, I'm venting," have been shy so far at distances where we expected at least a whisper. If this were a courtroom, the natural comet defense would open by waving around the size and the darkness. Big and black is what you get when soft ice and dust spend eons getting sandblasted by space. The missing early gases? A tough crust can bottle things up until the heat cranks higher, and an odd spin or patchy surface can delay visible venting. The weird isotopes are actually the most boring part of the case. Other stars have different chemical childhoods. If you freeze water in one of those nurseries, it won't carry our fingerprint. None of that needs aliens. It needs patience and better weather on Mauna Kea. But the prosecution, such as it is, points to the choreography. If you wanted a single pass to sniff a lot of our system without breaking a sweat, you'd plot something suspiciously close to this route. A Mars look when it's photogenic, perihelion on the far side of the sun where Earth can't snoop easily, a mid-distance Earth pass that's perfect for our big infrared eye, and a jump through Jupiter's magnetic storm to see how you hold up. Add in the inbound velocity on the high end of normal and a rotation that, so far, hasn't flinched much despite changing sunlight, and you get raised eyebrows. Not a verdict, eyebrows. So what rises above vibe and into testable, falsifiable stuff? 3 forks, no drama required. The first fork is the perihelion test. As the sun turns the dial, a natural body with buried ice should misbehave in very specific, measurable ways. Brightness should burble and stutter as jets switch on. The spin should wander by a hair's breadth as those jets act like tiny thrusters. And the chemistry should bloom in lines we know by heart. If we see that messy, honest bloom, the case leans hard toward rock with issues. If sunlight slams the thermostat and the thing stays nearly as composed as a bowling ball, that's not normal even for weird comets. We don't need miracles. We need a mismatch between heat and response. The second fork is the post-perihelion truth serum window in December. That's when Earth-side instruments stop guessing and start measuring tiny, boring details. The infrared fingerprints either line up with the outgassing we see, or we catch a faint accelerative nudge that refuses to match any gas we can account for. A tiny, clean push unaccompanied by the expected exhaust is what made Oumuamua such a headache. If 3IATLAS repeats that trick, but bigger and cleaner, it moves the goalposts from annoying to explain this without inventing a new type of comet. The third fork is Jupiter's field exam. Big, natural, dusty comets, coupled to magnetospheres in sloppy, diffuse ways we've cataloged for decades. If Juno's instruments see a tidy, narrow interaction where chaos should reign, or if the dust environment around the object behaves like something being managed rather than shed, that's one more quiet click in the same direction. None of these by themselves are smoking guns. Together, they become a pattern. Science loves patterns, especially the unsexy ones. Now the part where we label the shells clearly. Facts: size in the 10 to 12 kilometers band, dark surface, rotation near half a day. Inbound speed approximately 33 kilometers per second. Isotopic quirks and early reticence on classic comet gases beyond 2 astronomical units. Hypotheses: interstellar radiation can bake a crust that suppresses easy venting. The spin axis might be oriented to spread out heating in a way that delays visible activity. A carbon-rich, oxygen-friendly birthplace can leave organics that decompose differently under sunlight. Speculation: an engineered skin with pores that open when we can't see. A trajectory chosen not by luck, but by design to sample our system's greatest hits. A march through Jupiter's magnetotail to test shielding or harvest charged dust. Keeping those bins separate is the only way this stays sane. There's also the human factor, and we should say it out loud because it lives rent-free in all our heads. We look for faces in clouds and conspiracies in coincidences. Some of us grew up on stories where every blinking light was a visitor. Others wear skepticism like a badge that says it's never aliens. Neither reflex is helpful. The right middle is boring. Set predictions before the big moments, and then grade ourselves against those predictions without moving the goalposts. If perihelion yields a messy coma and a wobbly spin, we say so and we stop forcing the mystery. If it doesn't, we say so and we let the weirdness stand without flinching from where it points. Absence of evidence isn't evidence of absence. An old line goes. A grown-up addendum is, but it is evidence of absence of that thing above this threshold. Those thresholds, gas abundances, torque on the spin, thermal response are the whole game. Let's also be clear about uncertainty, because pretending it isn't there is how people end up angry at science. The size depends on reflectivity, which we estimate. The rotation period can alias if the light curve is tricked by shape and surface patches. The isotopes carry error bars that shrink with more photons. Even the trajectory's improbability comes with the big asterisk that selection bias loves to photobomb. We pay attention to showy paths and miss the wallflowers. That's not cheating. It's a reminder to be humble when we compute odds that sound like lottery tickets. But humility cuts both ways. Nature rarely draws straight lines. A dynamicist told me with a smile that had seen a lot of wavy plots. If 3I ATLAs keeps lining up its homework, hands it in early, and doesn't smudge the ink when the heat is on, we don't trip over ourselves to call that normal. We call it interesting. If we accumulate half a dozen small, consistent anomalies that keep pointing to not just ice and dust, we don't need fireworks to admit our models are missing a chapter. What happens to us, the species under each ending? If it's natural, it's not a shrug. It's a treasure. We get a pristine sample, another system's pantry, better constraints on how crusts form and break, a calibration check on our comet models, and a graduate course in how to organize an ambush of data across half the solar system. If it's natural, but truly odd, we expand the family tree. Not all comets are comets as we knew them, and that's a great problem to have. If it's artificial, even in a small, deniable way, a patch of surface too smooth, a push too clean, a thermal curve too composed, and we're living in a history chapter our great-grandkids will memorize. Not contact, not fireworks over Times Square, but evidence that someone older and quieter than us leaves small, careful footprints. That's enough to change how we talk about ourselves. There's an ethic tucked inside that possibility. If reconnaissance is out there ours someday, theirs today, then discretion beats drama. We'll have to grow up about how we beam our presence and how we interpret other people's shadows. That's not fear talking. That's fieldcraft. Scientists already practice it. Don't contaminate your sample. Don't bias your measurement. Don't choose the tempting test that ruins the next test. The sky rewards that discipline with answers you can defend. So where does the balance land tonight before perihelion throws real light on the problem? If you forced me to put a number on it over this napkin and a warm drink, I'd tell you the boring natural bet still holds the biggest share, because it always should, until something breaks in a way models can't patch. I'd also tell you there's enough off-kilter in the timing, the chemistry, and the early composure that we're not fools for keeping the non-natural folder open and tidy. Both things can be true. Being excited and cautious at the same time isn't a contradiction. It's the proper posture for standing under a night sky that loves to surprise us. And here's the real twist, the one that doesn't need aliens or headlines. 3-1 Atlas has already done something heavy. It made a lot of very serious people agree, across noisy time zones and pickier subfields, on exactly what would count as convincing. That's not small. We've had decades of arguing in circles about extraordinary evidence. This time, we've put down markers you can read aloud. How much gas, how much torque, how much heat, how much deviation. When the sun is done with its cross-examination, the grades won't be vibes. They'll be numbers, and numbers are how strangers agree. So yes, it's a rock until it isn't. It's a probe until it flinches. It's a mirror we're holding up to our own habits of hope and doubt. In a few moves Mars dawn, sun blaze, winter infrared, Jupiter's storm, we get to see which story survives contact with the universe. No incantations, no secret handshakes, just the oldest ritual there is. Point, measure, argue kindly, update. If 3I Atlas is hiding something big, it won't be able to keep the secret from heat, gravity, and a couple thousand caffeinated grad students. And if it's hiding nothing at all, that's still a kind of answer, the kind that builds the road for when the next visitor decides to stop being shy. All right, last round at the sticky table. We started with a nameless dot and a raised eyebrow, and we've walked it all the way to a picture you could defend in front of a grumpy committee. The question never changed. What exactly is 3I ATLAS? And could it be more than just another rock? But the way we hold it did. We've separated the sturdy from the squishy, and we've earned the right to make a calm promise about what happens next. Here's the steady ground we can stand on without wobble. We are watching a big, dark interstellar visitor, something like 11 kilometers across, spinning in roughly half a day, running a hyperbolic path that will not loop back for a second chance. Its surface throws back little light, which is exactly what old, carbon-rich crust tends to do. Its root hands are telescopes, a sequence of vantage points any mission planner would envy, and the spectra already whisper water ice and complex organics, with isotopic quirks that say, gently but firmly, I formed far from here. None of that requires a headline. It just requires you to feel the distance. On the shelf next to that, the shelf labeled reasonable but to be shown, we have the temperament problem. For something so icy, it has been oddly quiet on the way in. Where we expected greedy little gas lines lighting up the graphs early, we got a shrug. Maybe the surface really is crusted shut. Maybe interstellar radiation welded it tougher than our backyard comets. Maybe the spin and sun angle are stretching the heat, like a chef pulling sugar, so the first proper venting waits until the dial is higher. Every one of those is a sane, testable thought. And every one is an IOU that perihelion will cache. Then there's the third shelf, the one we keep locked because it's for stories that are allowed only if the light forces them. The careful choreography that smells like reconnaissance. The idea of a skin or structure that manages heat and thrust in ways that don't leave the usual messy fingerprints. The notion that a flyby could be both what it looks like and something more. These are speculations, not sins. They stay in the back room until the measurements knock. If they never do, we don't sulk. We close the door and thank the data for the lesson. What matters, now that we've built this whole scaffolding, is that the universe gets to decide which shelves empty out. The sun will turn up the thermostat soon enough. If 3I Atlas is a garden variety comet from a very distant garden, it will finally act like one. A coma will foam, the tail will sketch a bright line, the spin will twitch in ways we can model with coffee and patience, and the chemistry will read like a familiar cookbook with a few regional spices. If instead, the heap lands and the visitor barely flinches, if it takes the energy without the mess, if the tiny accelerations don't match the exhaust we can count, we'll have to admit the ordinary explanations need help. Not surrender, not melodrama, just the quiet honesty that says, our picture is incomplete. I know what you might be feeling, staring up into that big dark and waiting for something as unromantic as a spectrum to break your heart or light it on fire. But there's a kind of comfort in how unmagical the next steps are. We do not need secret keys or priesthoods. We need time on instruments, discipline about what we predicted, and the willingness to write the boring sentence that either closes the file or opens a new one. It's not as cinematic as alien fanfare, but it's how you build truth that sticks around once the excitement fades. There's also a human choice tucked inside all this, how we carry uncertainty without letting it sour into cynicism or inflate into fantasy. If you're the type who's allergic to maybe, the sky can feel like a tease. But the long game of astronomy is a carousel of not yet. The payoffs arrive with weird timing, and they usually look like plots that only a grad student could love. I think that's secretly the charm here. We don't have to wait for trumpets. We get to watch a question behave in public. We get to see how heat, gravity, and a handful of photons interrogate a mystery better than any talk show ever could. What about the bigger mirror this holds up to us? If everything about 3IA-TLAs ends up natural, we still win in the most practical way possible. We sharpen models for crusts and outgassing. We calibrate how different stellar nurseries stock their shelves. We learn how to orchestrate multi-planet observing campaigns without dropping a beat. We prove we can handle weirdness without immediately lighting the bonfire of speculation. And if a few edges don't file down, if the thermal response or the post-perihelion nudges keep that raised eyebrow raised, then we win a different prize. Permission to ask bolder versions of the same question, and a blueprint for how to recognize the line between unlikely and unnatural without moving the goalposts after the whistle. There's one more piece worth saying out loud, because it doesn't depend on which ending we get. We've been practicing how to agree. Across arguments and accents and time zones, people who rarely share a coffee have agreed on what would count as convincing. That's rare. That's culture moving in the right direction. Science is not the absence of doubt. It's a treaty about how to turn doubt into a shared map. 31ATLAS, whatever it is, has already helped redraw a little of that map. So here's my modest bar napkin closing. If you forced me to bet a slice of pie tonight, I'd still stake it on natural object with unusual manners. That's the wise bet, because nature gets the benefit of the doubt until it trips in a way we can measure. But I'm keeping a fork nearby, because the timing, the early composure, and the way the root curtsies to our best eyes have earned more than a casual glance. Either way, the good news is the same. We don't need to invent new organs to sense the difference. The instruments we've built, the checklists we agreed on, and the dates already on the calendar will tell us. If you've come this far with us, you're part of the experiment now. When the perihelion images drop, when the December spectral whisper, when Jupiter's field gets its say, ask yourself the only question that matters. Does this behave like ice and dust under stress, or does it behave like something that planned ahead? Not what you want, not what scares you, but what the numbers say when you stack them. If we can all promise to do that, we'll be the kind of audience the universe deserves. And now the fun part, the bit where you get to steer. If you enjoyed the ride, hit subscribe so you don't miss the big moments when the sun turns up the heat and the plot either thickens or dissolves. Drop a comment with a very specific answer to this. What would count as proof for you personally? A clean acceleration without matching exhaust? A thermal curve that shrugs off sunlight? A radar echo that looks too neat? Plant your flag now so we can come back and see who kept their word. And tell us this too. If 3I Atlas nudges the needle toward artificial, do we go quiet and watch? Or do we ping the dark with a hello? There isn't a consensus yet, and your take is part of the culture we're building. Finally, help pick our next mission. Do we chase the oldest rocks in the Oort cloud to build a control group for interstellar visitors? Do we call up the folks sketching an intercept mission and ask what it would take to slap a small, fast probe on a launch pad before the window closes? Or do we pivot to a different mystery? A weird fast radio burst, a rogue planet with too much heat, a moon with a saltwater ocean and a habit of spitting into space. Tell us where your curiosity points when the lights come up. However, the cards fall for 3I Atlas. Thanks for spending your attention on the quiet craft of not jumping to conclusions. The night sky doesn't owe us revelations on our schedule, but it has a long history of rewarding people who keep looking up with the right mix of wonder and restraint. We'll be here for the next turn. Same table, same napkin, same promise to label the shelves so no one gets lost. Until then, keep your eyes soft and your mind sharp. The universe is not in a hurry, but it is generous to the patient.